క్లియర్ ఆల్ కొట్టండి సార్, అక్కడ ఎరేజ్ ఆల్ అని ఉంటుంది. నేను ఓకే చెప్పగానే మీరు స్టార్ట్ చేయండి సార్.
ఓకే. Let us discuss few more memory based questions in chemistry. Here this question has been asked from phenol's chapter. Phenol treated with phthalic anhydride in presence of acid or H2SO4 followed by reaction with base. So he is asking the color of the product D. So if you know that phenol 2 moles react with phthalic anhydride in presence of acid, condensation reaction takes place. So we will be getting this product nothing but this is phenolphthalein. Phenolphthalein treated with base. So obviously we all know in practical chemistry that is it gives pink color, pink colored complex by opening this ring. So as per this, key for this question will be pink. Let us move on to the next question. This question is based on atomic structure. It is asking the wavelength of first line of Balmer as well as bracket series of hydrogen atom. If their wavelengths are lambda 1 and lambda 2 respectively, it is asking us to calculate the ratio of lambda 1 and lambda 2. So if you recall Rydberg equation, we all know that is 1 by lambda 1 is equal to R. Since it is Balmer hydrogen 1 square, Balmer series N1 will be 2 and first line is saying so it should fall from third. So it will be 9 minus 4, so 5R by 36. And similarly, if you calculate lambda 2, that is R, it is also hydrogen atom. For bracket series, Lyman, Balmer, Paschen, for bracket it will be 1 by 4 square and first line is asking so 1 by 5 square. So it will be 25 minus 16, that is 9R by 400. So since he is asking lambda 1 by lambda 2, we have to divide equation 2 with equation 1. So 9R by 400. So 36 by 5R. When you do it, so you will be getting 0.16, that is option 1 will be the answer for this question. Let us move on to third question, that is what will be the pH at 25 degrees Celsius of solution obtained by mixing 100 ml of 0.5 m ammonium hydroxide and 0.01 m 25 ml of ammonium chloride. If you see the composition carefully, we have ammonium hydroxide, its concentration is 100 into 0.5 millimoles and concentration of ammonium chloride 25 into 0.01 millimoles. So weak base we have and its conjugate acid is there. So they make buffer solution, that is basic buffer because weak part is basic here. So we use the formula POH, which is equal to PKB plus log concentration of conjugate acid by concentration of base. So PKB is given in the question itself, 4.74 plus log conjugate acid is 25 into 0.01. We are ignoring total volume in both the denominators since it is same, and 100 into 0.5. So when you calculate this, so POH will be getting that around 2.44. So PH is asking, so 14 minus 2.44. So our answer will be 11.56. So 11.56 is option A. Next question. This is asked from amino acids chapter, biomolecules and amino acids. Various amino acids have been given: arginine, lysine, aspartic acid and glutamic acid. Their codes, if you know, that is enough. We need not know essential or non-essential as per the question. So arginine code is NCERT based question. So it is R, lysine is K, aspartic acid D, glutamic acid E. So A with Q, B with P, R and S. So answer must be B. One more question. Day before yesterday also similar question was asked. Is asking arrange the following groups according to their decreasing order. Day before yesterday, certain groups have been given and asked IUPAC ranking, and now is asking their withdrawing power. Even if you know strongest withdrawing group, then also you can answer it because options are not closer. We all know that most crooked group, the group with most withdrawing power is NO2. Then comes CN, then COH, and then I. So as per that, our answer must be B. Okay, friends. Remaining questions will be discussed by our colleagues.
Vinod Babu, Nico.
Hello students, my name is Amit Tyagi and I will discuss some of the questions of today's first shift paper. Now you can see the first question here and it is from the chapter of surface tension. Radius of a soap bubble is increased from 1 centimeter to 2 centimeter. Work done in the process is S is a surface tension which is given to you. So as we know the change in surface energy, we can write delta U. This is equal to surface tension into change in surface area, that is A final minus A initial. So we can say this will be equal to the work done, which we have to find here. Now you can see for a soap bubble, now we have two surfaces, inner surface and outer surface. So here if I write A initial, so this will be equal to 2 into 4 pi r1 square. Be careful over here, we have two surfaces. So we need to multiply with 2 here. And similarly, we can write A final, that is 2 into 4 pi r2 square. So here we can put the values and with the help of this, we can calculate the work done, that is S in bracket 2 into 4 pi. R final we are writing, so R2 is 2 centimeter. So we have to substitute in meter over here. So 2 by 100 whole square minus 2 into 4 pi and R initial, that is 1 centimeter. So 1 by 100 whole square. Now in this 4 pi into 2 upon 10 to the power 4 will be common. So you can write S into 8 pi into 10 to the power minus 4 in bracket you'll get what, that is 2 square 4 minus 1 square, that is 1, so that is 3. So this will be equal to, you can write 2.4 into pi into S into 10 to the power minus 4 joules. So this is the answer of this problem. As you can see, that is option 3. Now next question, it is related to the geometrical optics chapter. A rod is placed along principal axis as shown. Find length of image. Now as you can see here, AB rod, that is placed along the principal axis, and in this focal length is given 10 centimeter and the distance of point A is given 20 centimeter from the mirror. So we can say the point A is placed at the center of curvature of the mirror. So here if we consider the situation which is given in the problem, AB is the rod, length of the rod is 10 centimeter. Now the image of point A of the rod will form at the same place because point A is where, at the center of curvature. Now the other end B, for that we can find the image by using the mirror formula. 1 by F is equal to 1 by V plus 1 by U, that is a mirror formula. Now we can put the value of F here, that is minus 10, concave mirror we have, is equal to 1 by V plus the value of U. Now value of U we can see over here, 20 centimeter plus 10 centimeter, so it will be minus 30. So if you solve this one, we'll get V, this is equal to minus 15 centimeter. So we can say here the image of point B will form at this place, and this length we have 15 centimeter, and this distance we have 20 centimeter. So length of length of image, we can write this will be equal to 20 minus 15 is equal to 5 centimeter. So for this problem, answer is option 2. Now this is the question of the nuclear physics. Given that nuclei A and B form a nucleus C, binding energy per nucleon for A, B and C are given 3 million electron volt, 7 million electron volt and 6 million electron volt. Then energy produced in the given nuclear reaction we have to find. So here we can write energy released in the process, energy, this will be equal to binding energy of C minus binding energy of B minus 2 into binding energy of A. And what values are given to us? That is binding energy per nucleons are given. So you can substitute in this. Binding energy of C will be what? That is 6 into 10. In C we have 10 number of nucleons. Then binding energy of B, that is 7 into 4, 4 number of nucleons in B, and binding energy of A, that is 3 into 3, number of nucleons in nuclei A we have how many? That is 3. So if you solve this one, this is 60 minus 28 minus 18, so 60 minus 46, so that will be equal to how much? That is 14 million electron volt. So this is the answer for this problem. You can say option C. Now there is a question related to the friction chapter. Given that find coefficient of friction if time taken by block in rough surface is 50% more than time taken by a smooth surface. The distance slide by mass is same in both the cases. Let us say for first case, on the smooth surface, time taken by the block to slide S, distance is T1. If I assume here for this it is T1 and here it is T2. So given that T2 is 50% more than T1, so we can write T2 is equal to 3 by 2 T1. Now on both the surface, the block is traveling the same distance for which we want to relate these two types. And here we can use the equation S is equal to ut plus half a t square, and in this equation u is what? 0, start from rest. The acceleration of the block on the smooth surface, that is g sin theta a1, g sin theta, and acceleration of the block on the rough inclined surface, that is what? G sin theta minus mu cos theta. Now we can equate the displacement in time t1 and t2. So we can write S is equal to u0 half g sin 45, theta is given 45 in both the cases, into T1 square, and this is also equal to half G sine 45 minus mu cos 45 into T2 square. Now both the side if you see, then G by 2 will be cancelled, and T2 we can substitute from here, that is 3 by 2 T1 in this equation. So we can write 1 by root 2 T1 square is equal to 1 by root 2 minus mu by root 2 into, I am putting T2 here in terms of T1, so it will become 9 by 4 T1 square, both the side T1 square cancel, and you can see here root 2 is also cancelled. So we can write multiply 4 over here, 4 is equal to multiply 9 inside the bracket, 9 minus 9 mu. So from here we can write mu, this is equal to 5 by 9. So coefficient of friction for the rough surface, that is what, 5 by 9. You can see over here clearly the option 2, that is the correct answer for this problem.
Good morning everyone. Welcome to Narayana Educational Institutions. So today 4th of April, morning shift paper, memory based, some of the questions have started pouring into our team, and we are starting today with chemistry. We have got few questions. Let us discuss them. First question we got is of organic. As you can see, again, yesterday also the questions from electrophilic aromatic substitutions were there in both morning and evening shift. And here again you can see the question from electrophilic aromatic substitution is there. So all those who are preparing for future sessions or shifts should definitely do this particular chapter very carefully. Now, what is the first reaction? I hope all of you remember this particular first reaction, that is CH3ClAlCl3, is a very well-known reaction, Friedel-Crafts alkylation. Right? This is Friedel-Crafts alkylation. Okay, so let's start making solution. If it is benzene, CH3ClAlCl3 is given, then toluene is formed. Right? Now they are saying chlorine and AlCl3. What it is? It is simple halogenation of aromatic ring. But here my aromatic ring is already substituted, already CH3 is there, so I have to take care of the directive influence. CH3 is hyperconjugative, or I should say plus H and plus I. So it is ortho-para directing. Out of the two, nothing is said about major or minor. I'm writing both. Whatever you might have taken, you would land up to the same answer. Either. Okay. Now they are saying oxidize it with K2Cr2O7 under acidic conditions. Under acidic conditions, K2Cr2O7, alkaline KMnO4, acidic KMnO4, all of do same function. That is, the CH3 will be oxidized to COOH. So whichever X you consider, it is going to be the same answer. I am taking this para one as forward because of steric factor. Usually we prefer para. Okay. So now the question says P gram of X. We have got the X, but they are asking the P gram. So I would definitely need the molecular weight of X. What is X? C7H5O2Cl. When I'll calculate, it is 156.5 grams. Right? It is carboxylic acid, and from carboxylic acid, all of you must be remembering this important acid-base reaction where carboxylic acids displace H2CO3 from NaHCO3 solution, sodium bicarbonate solution, and we obtain brisk effervescence of this CO2. Right? So if there is one acidic H as we have in X, right? So 1 mole of CO2 is liberated. Yes, there is a little thing that they have given 11.2 dm of gas obtained at STP, right? Whether it is a new STP or an old STP, for new STP it should have been I think 11.35, but anyways, if they are giving 11.2, we definitely have to take that hint that use 22.4 liters for STP. That is the old calculations we have to go for. Anyways, coming back here, so I can see that 22.4 liters of CO2 will be liberated by 156.5 grams of P. So, question is asking 11.2 liters of CO2. So, it will be liberated by 156.5 upon 22.4 into 11.2 grams. If we'll solve this value, you will get something like 78.25 grams, but answer is to be given as the nearest integer, so answer will be 78 grams, or you will put 78 in your response sheet. Okay. If there is any further question, you can ask in the comment. Moving to the next question, match the following. So list 1 seems to be certain name reactions, and list 2, let us say, are the reagents or the different chemicals involved in that particular name reaction. If you see, all these reactions are mentioned in NCERT, right? Finkelstein and Schwarz in alkyl halide chapter, you will find Finkelstein is any alkyl halide. You treat it with NaI and acetone and you get Ri. That was Finkelstein. So 1 should match with P, right? Moving to second, Schwarz. Now Schwarz is, you have RCl or RBr or Ri. You treat it with various halides including SbF3, you can have cobalt halides, you can have silver, mercury, so many again given in the NCERT, but here as SbF3 is given, formation of Rf is observed. So for Schwarz, the matching goes with S. Coming to third, Fittig reaction. Now Wood's Fittig reaction is basically aromatic halides or iodides. They react with alkyl halides in presence of sodium and brine. It is an extension of Wood's reaction and we get alkyl aryl compounds. So this third will match with Q. Moving to fourth, that is Sandmeyer reaction. Sandmeyer reaction is of diazonium compound N2 plus Cl minus. We treat it with Cu2Cl2 plus HCl. You can have Cu2Br2 plus HBr or cyano and we get corresponding product. Here chlorobenzene. So 4 goes with R. There must have been some options which are still not available with us in the exact format. So whatever the options are, this should be the correct match for the 2 columns. Okay. Moving to next question is from Inorganic. Total number of lone pairs and sigma bonds pairs formed by central atom xenon in XeO6 4 minus. Now this XeO6 4 minus is called perxenate ion and it has regular octahedral geometry. Okay, it is a regular octahedral geometry. So xenon, oxygens like this. Then we have like this. Important point to note is there is resonance, right? All of these will be in resonance with each other. So let me tell you one more extra point. All xenon oxygen bonds are of equal length. So xenon-oxen bond length are equal here due to resonance. Okay, they are all equal. Coming back to the question, so how many lone pairs are there on xenon? 0, because it has formed 1, 2, 3, 4, 5, 6, 7, 8 bonds. There is no lone pair left. Okay, then is number of sigma bond pairs. Sigma, so 1, 2, 3, 4, 5 and 6. The question is asking total number of pairs, total number of these two. So 0 plus 6 equal to 6. Answer for this question should have been 6. Okay, moving to next inorganic question, which is, I think, boiling point all of you must have done correctly. Melting point may be a little dicey. Okay, it is given in the NCERT, so you were expected to know. Let me write the correct order. Okay, and then we'll see which option is correct. So for boiling point, as per our studies or as per our NCERT, it is this HF. Okay, good. They have given HF. But after that, it should be HI. They have given HCl. HCl should be in the last. HI should be here. So that makes this first statement false. Coming to melting point. Melting point, HI has the maximum. Then comes HF. Then HBr. And then comes the HCl. Okay, this is the melting point order. Let us check. They are writing HBr at the top. So this makes second statement also false. Let us select the answer. 1 and 2 both are correct? No. 1 and 2 both are wrong? Yes. So answer for this question have been B or 2 in whatever format it appeared in your paper. Okay, moving to next question. Biomolecules. Given below are two statements. Maltose is a non-reducing sugar. ये तो पढ़ते ही लग रहा है कि this one is false because both maltose and lactose were reducing sugar. Sucrose was the one which was non-reducing sugar. So this is true. Lactose is a reducing sugar. Right? Let us revise what was maltose. So let me tell you, maltose is a disaccharide of alpha D glucose. That is, two molecules of alpha D glucose joined together. Connection connect at C1 and C4 of monomers. Okay, carbon number 1 glycosidic linkage to be formed from carbon number 1 of alpha D glucose, and the next bond is from carbon number 4 of next alpha D glucose. Overall, it behaves reducing, right? So that makes our first statement false. Moving to lactose. How does lactose behave? Well, what is lactose? Lactose has both beta, but what are those both? So beta D galactose is bonded to beta D glucose. Okay, the glycosidic linkage used is of galactose. So C1 of galactose bonds to C4 of glucose. C1 of glucose is left now for reduction behavior for all those reactions, and thus it behaves reducing in nature, and certainly it is also a disaccharide. Okay, this one is also a disaccharide. So we found what is the answer? First is false, second is true. So first is false and second is true. It seems C or third is our answer, or 3, whatever there in your format. Correct? So these are the 5 questions from chemistry. We are getting more. Be in line, be in touch, don't switch channels, and we'll get you some more questions.
Hi everyone.
I am Prasad Babu, Senior Mathematics Lecturer in Narayana Educational Institutions. Today we will discuss Session 2 JEE Mains 4th April Mathematics paper. So see the first question. Given A containing 5 elements 1, 2, 3, 4, 5 and B a set containing 3 elements A, B, C. We want the number of functions which are not onto. It's a direct formula based question. You know, if number of elements in A is m and a number of elements in B is n, then the number of onto functions is equal to n power m minus nc1 into n minus 1 whole power m plus nc2 into n minus 2 whole power m minus and so on, alternative signs. So in this example, m is 5, n is 3. Therefore, number of functions which are not onto is equal to total number of functions minus number of onto functions. Number of onto functions, just now we wrote a formula, just substitute here, plus nc2 n minus 2 whole power m minus and so on. Now n is 3, m is 5, so it is 3 power 5 minus 3 power 5 minus 3c1 into 3 minus 1, that is 2 power 5 plus 3c2 into 3 minus 2, 1 power 5. Next you get 0. This is the last term in this series. So if you simplify this, we get 93. So it is a simple question. Just number of functions minus number of onto functions will give the number of functions which are not onto. Now coming to the next question. If z be a complex number such that mod of z plus 2 is equal to mod of z minus 2 and argument of z minus 3 by z plus I is pi by 4. We want the complex number z. You can do this by verification, just substituting options in this conditions given, or you can do direct also. Here given that mod of z plus 2 is equal to mod of z minus 2. It is very clear that z lies on the perpendicular bisector of line joining minus 2 comma 0 and 2 comma 0. That is nothing but y axis. Its equation is x is equal to 0. So see this is the coordinate axis. Here we have 2 comma 0, here we have minus 2 comma 0. Now the perpendicular bisector of line joining these 2 points is the y axis. Now our z satisfies y axis as well as this one. This argument of z minus 3 by z plus I is equal to pi by 4 is a circular arc which this chord joining 3 comma 0. Here take 3 comma 0, z minus 3 na 3 comma 0 and 0 comma minus 1 is the chord, and the z satisfies argument of z minus 3 by z plus I lies on this circular arc, and we want z, that is intersection, that lies on this circular arc as well as on the y axis, that is this point. Now this point we get, and at this point, according to the data, the angle made by the line joining AB is pi by 4. This is pi by 4. And clearly this is 90. So this is also pi by 4. So this ABC, not ABC, OBC, is an isosceles triangle. So OB length same as OC length. So C is a point on y axis. That's why C is 0, 3. Now the required Z is 3i. It is a geometrical application of complex numbers. So for that you must know the complex number Z satisfies mod of Z minus Z1 is equal to mod of Z minus Z2 is the perpendicular bisector of line joining Z1, Z2, and the argument of Z minus Z1 by Z minus Z2 is theta, is a circular arc, corresponding chord joining is Z1, Z2. So using just geometry, we get directly this required Z is 3i. Now coming to the next question. AB a square matrix of order 3 such that det A is minus 4, then the value of det adjoint of 2 adjoint A whole inverse. It is the properties based on determinant of adjoint A and determinant of A inverse. You know, if A is a square matrix of order n, determinant of adjoint A is det A power n minus 1 square. Here n is 3, so that's why determinant of adjoint of 2 adjoint A inverse is equal to, so this is our A now. So using this property, that is det adjoint of adjoint A is det A power n minus 1 square, we have this one. So this is det 2 adjoint A inverse whole power n minus 1 whole square. Here n is 3, 3 minus 1 is 2, 2 square is 4. And we also know that det Ka is k power n into det A, and also det A inverse is 1 by det A. So this det 2 adjoint A whole inverse can be written as 1 by 2 adjoint A det power 4, and this is 1 by, when you take these 2 outside this determinant, this will be 2 cube. So it is 1 by 2 cube whole power 4, nothing but 2 power 12 into det adjoint A whole power 4. And we know det adjoint A is det A power 2. So given here det A is minus 4. So it is 1 by 2 power 12 into minus 4 whole power 4. This is 1 by 2 power 12 into minus 4 whole power 4 is 2 power 8 minus 4. Det adjoint A is det A whole square here. So it is minus 4 whole square whole power 4. That is minus 4 whole power 8. That is 1 by 2 power 12 into 2 power 16. That is 1 by 2 power 28. These are all properties of determinant of adjoint A and determinant of A inverse. Two properties used in this one. One is determinant of adjoint A is det A power n minus 1 square. And second one, determinant of adjoint A is det A power 2. And det A inverse is 1 by det A. And det Ka is k power n into det A. So using those, we get the value of det adjoint of 2 adjoint A inverse is 1 by 2 power 8. Coming to the next question. The number of ways 4 boys and 3 girls are to be arranged in a row so that all 3 girls are not together. It's a very simple question. Required number of ways is nothing but total ways of arranging 4 boys and 3 girls, total number of ways minus number of ways in which all 3 girls sit together. Number of ways all 3 girls sit together. Total number of ways, total 7 persons are there. They can be arranged in a row in 7 factorial. And to get number of ways in which 3 girls sit together, take the 3 girls as one unit. So 3 girls unit and 4 boys. Total we have 5 things. They can be interchanged in a row in 5 factorial ways. And the girls in that unit can be interchanged in 3 factorial ways. So total number of ways in which all girls sit together is 5 factorial into 3 factorial. If you simplify this one, take 5 factorial common from these two. If you take 5 factorial from this 7 factorial, it is 7 into 6, 42, minus 3 factorial, that is 6. This is 120 into 36. This will give 4320. It's a very simple question. And coming to the next one, given y, tan inverse 3 cos x minus 4 sin x by 4 cos x plus 3 sin x plus tan inverse x by 1 plus root of 1 plus x square. We want value of dy by dx at x is equal to root 3 by 2. Before finding dy by dx, first simplify this expression given. Here we have two terms there, this one and this one. First I am taking the first one, that is tan inverse 3 cos x minus 4 sin x by 4 cos x plus 3 sin x. So to simplify this, divide numerator denominator with cos x so that we get the terms inside the bracket in terms of tan. It is 3 minus 4 tan x by 4 plus 3 tan x. So to get a form, tan inverse x minus y by 1 plus xy, divide numerator and denominator with 4. So it is tan inverse 3 by 4 minus tan x by 1 plus 3 by 4 into tan x. Now it is in the form tan inverse x minus y by 1 plus xy. That is tan inverse x minus tan inverse y. Nothing but tan inverse 3 by 4 minus tan inverse tan x, that is x. This is the first expression. And coming to the second one, for second one, we have to take a substitution, x tan theta. So it is tan inverse x by 1 plus root of 1 plus x square. When you take x tan theta, then this become tan inverse tan theta by 1 plus secant theta. Root of 1 plus x square is 1 plus tan square theta, that is secant square theta, under root secant theta. Now write this tan theta sin by cos and secant theta is 1 by cos theta. Then it will become tan inverse sin theta by 1 plus cos theta. So converting this into half angles, you can write sin theta 2 sin theta by 2 cos theta by 2, and 1 plus cos theta is 2 cos square theta by 2. Then it is tan inverse tan theta by 2. Writing sin theta as 2 sin theta by 2 cos theta by 2, and cos 1 plus cos theta is 2 cos square theta by 2. then we get it is tan inverse tan theta by 2, nothing but theta by 2. And theta is, according to substitution, it is tan inverse x. Therefore, y become, first expression is tan inverse 3 by 4 minus x after simplification, and second one is theta by 2. Here theta is tan inverse x. Now find dy by dx. Tan inverse 3 by 4 is a constant. Tan inverse 3 by 4 is a constant. So derivative of a constant is 0 and x derivative 1, and tan inverse x derivative 1 by 1 plus x square. Now we want dy by dx at x is equal to root 3 by 2. So substitute x root 3 by 2. So dy by dx at x is equal to root 3 by 2. This is minus 1 plus 1 by 1 plus 3 by 4. This is minus 5 by 7. Just to simplify the two expressions given, then finally you get a simple expression y, then direct differentiate and substitute x root 3 by 2. Okay.
Hi everyone, this is Subramanian, Mathematics faculty, Narayana Group. Now the sixth question in mathematics. The domain of the function cos inverse of 4x plus 2 integral part of x upon 3, where bracket is the greatest integer function is. This type of question already in the first, that is in the last session also we discussed. So the same pattern question here, the domain of the function cos inverse of 4x plus 2 into integral part of x upon 3. Now we are very well known that the cos inverse x is defined. Cos inverse x is defined only when the argument lies between -1 and +1. So here 4x plus 2 integral part of x upon 3 lies between -1 and +1. So 4x plus 2 into integral part of x lies between -3 and +3. That is, cos inverse x is defined -3 is less than or equal to 4x plus 2 times of integral part of x is less than or equal to 3. Then the cos inverse function is defined. Otherwise, the function is not defined here. So, -3 is less than or equal to 4x plus 2 into integral part of x is less than or equal to 3. Now, here observing 4x plus 2 into integral part of x is less than or equal to 3, the expression contains greatest integer function. That's why definitely here we are going to check the cases. That is, first of all, suppose if we consider case 1, x belongs to 0, 1, I consider. When we consider the x belongs to 0, 1, suppose it is case 1, when x belongs to 0, 1. If x belongs to 0, 1, then we know that integral part of x is equal to 0. Integral part of x is equal to 0. And the inequality becomes as -3 is less than or equal to 4x is less than or equal to 3. Now from this, minus 3 by 4 is less than or equal to x is less than it is. So x is less than 3 by 4. X is less than 3 by 4. Now here x belongs to -3 by 4 to 3 by 4, but whereas the domain in this case we consider as x belongs to semi-closed interval 0, 1. That's why it is 3 by 4 is, you know, that 0.75. Therefore, x belongs to, by combining these values, 0 to 3 by 4, where 3 by 4 does not include here in this case. 3 by 4. It is 3 by 4, or it is less than or equal to there. Less than or equal to means definitely it is included. It is included. 0, 3 by 4. Like this, we consider the next case also. The next case means I consider x belongs to case 2. Case 2. X belongs to negative case I consider, that is -1, 0 I consider. When x belongs to -1, 0 means integral part of x is equal to -1. Then the inequality, observing the inequality here, -3 is less than or equal to 4x plus 2 times of integral part of x is less than or equal to 3. That is, -3 is less than or equal to 4x minus 2 is less than or equal to 3. Now we are trying to simplify this one. -2, we are adding 2 to the entire inequality. Then -1 is less than or equal to 4x is less than or equal to 5. Now dividing with 4, -1 by 4 is less than or equal to x is less than or equal to 5 by 4. Whereas observing here, that is x belongs to -1, 0. Here -1 by 4 is less than or equal to x is less than or equal to 5 by 4 means clearly it is very clear x belongs to, therefore x belongs to closed interval -4, 0. Closed interval -4, 0. In all the remaining cases it is not defined. That is, just you consider the union of domain becomes as domain is x belongs to -1 by 4, 0 union. In the first case we know that 0, 3 by 4, 0, 3 by 4, 0, 3 by 4. Therefore, x belongs to closed interval minus 1 by 4 minus 1 by 4 comma 3 by 4. Observing the options. Once you observe the options, third option is right for this one. Third option is correct. The problem is time taking and it involves the especially greatest integer function. Be cautious. Now the next one. Let Sn is the sum of first n terms of an AP and An is the nth term of AP. If first term of the given AP is 10 by 3 and S30 is equal to A30 whole cube, then the common difference of the given AP they are asking. As usual, we are solving this problem by using the AP series, but here somewhat it is different, that is S30 is equal to A30 cube is given. So here to solve this problem, first A1 is given, A1 is 10 by 3, first term is 10 by 3 and the relationship between S30 and A30 whole cube is given. Suppose let I consider common difference as D. Common difference is equal to D. Then A30 means we know that A30 is equal to first term 10 by 3 plus n minus 1 into D, n minus 1 into D, n minus 1 into D. Here n is equal to 30, hence this becomes as 10 by 3 plus 29D. This is A30. This is A30. Now S30, we know that S30 means sum of the 30 terms of AP. Sum of the n terms of AP, we have the formula. The formula, once you recall, here n by 2 into A plus L, where L is the last term. L is the last term. In this case, L is the 30th term. That's why here A1, this is the first term plus L. That is, this one is equal to, we are writing 15 times of A1 is 10 by 3 plus L is A30. L is A30. That is S30 is equal to 15 times of 10 by 3 plus A30. Now the given relation we are using here. The given relation is S30 is equal to A30 cube. S30 is equal to A30 cube. Since S30 is equal to A30 cube. S30 we know that is S30 is 15 times of 10 by 3 plus A30 is equal to, this is A30 cube. Now here observing, we get a cubic equation. A30 cube minus 15 A30 and minus 50 is equal to 0. By inspection method, we are solving this equation. Observing the 50 factors are, since 50 is equal to 5 into 10. I am going to check A30 is equal to 5. By substituting A30 is equal to 5, this becomes 5 cube, it is 125 minus 15 into 5, 75, 15 into 5 minus 50. This one is equal to 0. Hence, therefore, A30 is equal to 5. A30 is equal to 5. We get A30 is equal to 5. Now A30, we have the formula. A30 is 10 by 3 plus 29D is equal to 5. From this, 29D is equal to 5 minus 10 by 3 is equal to 5 by 3. Therefore, D is equal to 5 upon 29 3 is the 87. D is equal to 5 by 87. Observing the options, the first option is right. First option is right. Frequently in the JEE Mains, this type of questions asked. Next one is, if integral minus 2 to 2 mod sin x plus mod x sin x dx is equal to beta times of 1 minus 3 cos alpha plus beta times of sin beta, then beta is equal to, they ask. The question is related to, very well known, this one is definite integration, and observing here the integrand. Integrand, suppose if I consider f of x is equal to mod sin x plus mod x sin x. Now the limits are minus 2 to 2. When the limits are minus 2 to 2, we are going to check whether the given integrand is, whether it is odd function or even function, or it is the odd and even function, we don't know exactly. So that's why we are going to check, that is f of minus x is equal to mod sine of minus x plus mod minus x sine of minus x is equal to, we get mod sine x plus mod x sine x. That means we know that f of x is an even function. F of x is an even function. If f of x is an even function, we have the property, that is integral minus a to a, integral minus a to a, f of x dx is equal to, f of x dx is equal to, we have the property integral 0 to a f of x plus f of minus x dx. So by using this property, we get here f is an even function, hence this becomes as 2 times of integral 0 to a f of x dx. By using this property, we are going to solve this one. So here, first of all, we are writing, let I is equal to, let I is equal to 2 times of integral 0 to 2, integral 0 to 2 mod sin x plus mod x sin x dx. Now this is equal to 2 times of integral 0 to 2. In 0 to 2 interval, sin x is positive because 2 is less than pi. Hence, mod sin x becomes as sin x plus mod x sin x also becomes as x sin x dx. Now this is equal to 2 times of integral 0 to 2. By taking sin x common, 1 plus x times of sin x dx. I am applying by parts here. Applying the by parts, that is, I consider this one as the first function and sin x as the second function. Applying the by parts, this is equal to 2 times of, applying the by parts, it becomes as 1 plus x, and integral sin x becomes as minus cos x, and the limits are 0 to 2, 0 to 2, minus integral 0 to 2, 2 times of integral 0 to 2, 1 plus x derivative is 1, integral sin x dx becomes as minus cos x, minus cos x dx. Now this is equal to 2 times of, applying 2 here, minus 3 cos 2, minus 3 cos 2, applying 0, this becomes as minus of minus 1, minus 2 times of, minus minus plus is here, 2 times of integral 0 to 2 cos x is here, that is sin x, integral cos x is sin x, 0 to 2. Now this is equal to 2 times of 1 minus 3 cos 2 plus 2 sin 2. Comparing with the given equation, you observe here, beta times of 1 minus 3 cos alpha plus beta sin beta, comparing, beta is equal to 2. Beta is equal to 2. Hence, the correct option is, second option is right. Second option is right. Problem level is very simple. It is property based. So, everyone try this one. It is property based. Next. If A is equal to sin 3 degrees by cos 9 degrees plus sin 9 degrees by cos 27 degrees plus sin 27 degrees by cos 81 degrees, and B is equal to tan 81 degrees minus tan 3 degrees, then the value of A by B is equal to, the value of A by B they asked here. First of all, observing the expression sin 3 by cos 9, sin 3 by cos 9, here the 9 degrees is 3 times of 3 degrees. Similarly, sin 9 degrees by cos 27 degrees, 27 is also 3 times of 9 degrees. That's why we can, first of all, we can try to solve sin theta. It is sin theta by cos 3 theta model. And to simplify this one, we are converting this one into the collapsing series model. For that purpose, you multiply the numerator and denominator with the cos theta. Then this becomes as sin theta into cos theta by cos 3 theta into cos 3 theta into cos theta. And you multiply the numerator with 2, divide with 2. Then this becomes as 1 by 2 times of sin 2 theta upon cos 3 theta into cos theta. Now this sin 2 theta can be written as 1 by 2 times of sin of 3 theta minus theta. In terms of the denominator arguments, I am expressing the numerator. Sin of 3 theta minus theta upon cos 3 theta into cos theta. Now this is equal to 1 by 2 times of sin A minus B formula we are using here. Sin A cos B minus cos A sin B, and the proper cancellations, it gives us tan 3 theta minus tan theta. So sin theta by cos 3 theta is equal to 1 by 2 times of tan 3 theta minus tan theta. By substituting theta is equal to 3 degrees, we get sin 3 degrees upon cos 9 degrees is equal to 1 by 2 times of tan 9 degrees minus tan 3 degrees. Similarly, here for the second term, we are applying theta is equal to 9 degrees. Applying the theta is equal to 9 degrees, sin 9 degrees upon cos 27 degrees is equal to 1 by 2 times of tan, here 3 theta, that's why 81 degrees minus tan 9 degrees. When we are applying theta is equal to, for the last one, 27 degrees, we get here sin 27 degrees upon cos 81 degrees is equal to 1 by 2 times of tan 3 theta, that becomes 81 degrees minus tan 27 degrees. Observing, if we are adding, the left hand side gives us A. In the right hand side, by adding, all these are the cancelled. That is, here tan 9 degrees, tan 9 degrees, tan 81 degrees, and observe here, this becomes as tan 81, and this becomes as tan 81, tan 27. This is tan 27 degrees. Tan 27 cancelled. Now we are with tan 81 degrees minus tan 3 degrees 1 by 2. That is, A is equal to, here we get 1 by 2 times of tan 81 degrees, tan 81 degrees minus tan 3 degrees. Now, observing the problem, tan 81 degrees minus tan 3 degrees is B. I am substituting here 1 by 2 times of B. So, from this, A by B is equal to 1 by 2. A by B is equal to 1 by 2. A by B is equal to 1 by 2. Third option is right. Third option is correct for this one. This problem in Narayana material also there. Once you check, this type of problems, so many are there. Once you check everyone. Next one. Suppose that two chords are drawn from the point 1, 2 on the circle x square plus y square plus x minus 6y is equal to 0 are bisected by the y-axis. If the order of ends of these chords are R and S, and the midpoint of the line segment is PQ, then 6 times of P plus Q they asked. That is, two chords are drawn from the point 1 comma 2 here. For the circle equation is x square plus y square plus x minus 6y is equal to 0. Suppose I consider this one as S. Now, yes, the position of 1 comma 2 point, I am going to calculate here 1 plus 4 plus 1 minus 6 times of 2. It is less than 0. Maybe the problem is here, it is memory based, hence maybe it is 3. If it is 3, then the problem becomes as like this one. If it is 3, then here is 3. It is 3, then exactly this becomes 0. So S12 is equal to 0. That means the point lies on the circle. If the circle equation is x square plus y square plus x minus 3y is equal to 0, then the given point 1 comma 2 lies on the circle. Now, from that point, the chords are drawn. The chords are drawn which are bisected by the y-axis. That is the total scenario like this one. Suppose this is the circle and this is the y-axis. This is y-axis. Somewhere P point is here or any side, that is P1 comma 2 is there. That's why I consider this side P1 comma 2 point. Two chords are drawn like this and these chords are bisected by the y-axis and the endpoints are R and S. Now this is the midpoint. Suppose I consider the midpoint M. Now it is very clear. The midpoint lies on y-axis. If the midpoint lies on y-axis, then x coordinate is, you know that, 0 and y coordinate we don't know. Y coordinate I am taking as k. That is, let M 0 comma k be the midpoint of chord, midpoint of PR bar. Then R coordinates becomes as R is equal to, we have the formula that is 2m minus p. This is equal to 2m minus p. This becomes as minus 1 and 2k minus 2. R points becomes as minus 1 comma 2k minus 2. Since R lies on the, R lies, here R lies, here differently I am using the, this is suppose T, this is T. R lies on the circle. So, R coordinates satisfy the circle equation. R coordinates are minus 1 whole square 1 plus y square 2k minus 2 whole square plus x is minus 1 minus 3 times of y coordinate 2k minus 2 is equal to 0. Now, here it is very clear, plus 1 minus 1 are gone and both are having 2k minus 2 common. By taking 2k minus 2 common, 1 minus 1 minus 3, that is here 2k minus 2, 2k minus 2 and here is minus 3 is equal to 0. So, from this k is equal to 1 and k is equal to 5 by 2. The values of k are k is equal to 1 and k is equal to 5 by 2 or in this case 2k is equal to 5. Then the points becomes as r is equal to, r coordinates are minus 1, r coordinates are minus 1 comma 2k minus 2, 2k minus 2 is equal to 0. 2k minus 2 is equal to 0. Hence, r coordinates are minus 1 comma 0 and t coordinates are minus 1 comma, here is 2k is equal to 5. So 2k is equal to 5. 5 minus 2 is 3. It is 3. It is 3. Now they asked the midpoint of RT bar. Midpoint of RT bar is P comma Q. So P comma Q is equal to minus 1 comma 3 by 2. They asked for 6 times of P plus Q. 6 times of P plus Q is equal to 6 times of minus 1 plus minus 1 plus 3 by 2. Now this is equal to 6 times of 1 by 2 is equal to 3. It is 3. There is no option, maybe it is numerical. So the required value is 3. Next question. Let f of x is equal to f dash of x into f double dash of x and f of 0 is equal to 0, where f of x is a polynomial function of nth degree. The value of 36 times of f dash of 2 plus f double dash of 2 plus integral 0 to 1 f of x dx. The problem is related and mixing with the calculus part, related to the calculus part entirely, mixed with the differentiation and integration also. So here first of all, f of x is a polynomial function of nth degree, then f dash of x is n minus 1th degree, f double dash of x is n minus 2, that is n minus second. That is the degrees, observing the degrees here, f of x is a polynomial function of nth degree. So f dash of x is n minus 1, n minus 1th degree, and f double dash of x is n minus 2 degree. So here f of x is equal to f dash of x into f double dash of x. Hence the degree is n is equal to n minus 1 plus n minus 2. So from this n is equal to 3. That is f of x is a cubic polynomial. F of x is a cubic polynomial. F of x is a cubic polynomial and f of 0 is equal to 0. That means there is no constant at all. That's why here we are going to be write f of x as f of x is equal to ax cube plus bx square plus cx only. Ax cube plus bx square plus cx, because of f of 0 is equal to 0. Now from this f dash of x, you know that 3ax square plus 2bx plus c, and f double dash of x. F double dash of x is f double dash of x. F double dash of x is f double dash of x is equal to 6ax plus 2bx, that means 2b. This is f double dash of x. F of x is equal to ax cube plus bx square plus cx. Then f dash of x becomes as 3ax square plus 2bx plus c, and f double dash of x becomes as 6ax plus 2b. 6ax plus 2b. Since what they are given observing, f of x is equal to f dash of x into f double dash of x. F of x we consider ax cube plus bx square plus cx is equal to f dash of x is 3ax square plus 2bx plus c into f double dash of x is 6ax plus 2b. Now LHS and RHS are the polynomials. We are comparing the like terms coefficients. Comparing x cube coefficient first of all. Comparing the x cube coefficient, left hand side a is equal to, right hand side becomes 18 a square. So, from this a is equal to 1 by 18. Next, we are comparing the constant terms. Left hand side there is no constant term. Right hand side there is a constant term. That is comparing x to the power of 0 coefficient, 2bc is equal to 0. So, from this b is equal to 0 or c is equal to 0. Now, I am going to check when c is equal to 0, if you consider c is equal to 0 by substituting here c is equal to 0 or b is equal to 0. First, I am going to taking b is equal to 0. By substituting b is equal to 0, the equation becomes as, that is x coefficient. I am comparing the x coefficients. C is equal to this side x coefficient is equal to 0. That's why totally here the polynomial becomes as f of x is equal to b is equal to 0, c is equal to 0. So, hence the polynomial becomes as ax cube. Ax cube means x cube by 18. This is f of x. Now, from this we get f dash of x. F dash of x is equal to 3x square by 18. That is equal to, we get x square by 6. And f double dash of x we get. F double dash of x is equal to, we get 2x by 6. This one is equal to x by 3. Now, f dash of 2, from this part we get the f dash of 2. F dash of 2 is equal to 2 square by 6. 2 square by 6 means 2 by 3, and f double dash of 2, here we get f double dash of 2 is also 2 by 3, integral 0 to, observing integral 0 to 1, they asked integral 0 to 1 f of x dx 1 by 18 times of integral 0 to 1 x to the power of 4 dx 1 by 18 into x to the power of 5 by 5, that is 1 by 5 we get. By adding all these we get the answer actually. By adding all these, the required one, what they asked, see there once, this is 36 times of they asked. So, first of all we are going to write here f dash of 2 plus f double dash of 2 plus integral 0 to 1 f of x dx is equal to, this is 2 by 3 plus 2 by 3 plus, that is 1 by 18 into 1 by 5, 1 by 90. Now 36 times of they asked 36. Now this one is multiplied with 36. This is equal to 24 plus 24 plus 36 by 90. This is equal to 48 plus 36 by 90. 36. Once again you recheck. The calculations are 1 by 18 x cube by 18. So, integral 0 to 1 x cube is here. Careful. Here is x cube. Here is x cube. X cube, that means here we get 1 by 4. 1 by 4. Then here this becomes as 72. This is 72. 72. This is 72. 36 by 72 is equal to 1 by 2. So 48.5. 48.5. Observing, this is 48.5. Option 3 is right. Option 3 is right. So, in overall, all the problems are somewhat lengthy, and here observing all the models are frequently asked models. So, be careful, and every student should try the solve the previous question papers also. That is very helpful to you. It is very helpful to you.
Hello everyone. Today we will discuss few memory based questions related to JEE Mains Phase 2 April 4th morning shift. Here we will discuss few questions memory based related. In that first question, if you see here, and they gave here that for the reaction A plus B gives rise to C, K equilibrium is equal to 2.7 into 10 power minus 5. And they are asking about calculate the K equilibrium for the reaction is 1 by 3 A plus 1 by 3B gives 1 by 3C. Here the first reaction is just multiplied with the factor 1 by 3. When the reaction is multiplied with the factor, some factor n, the equilibrium constant of that particular reaction is going to be changed, and the new equilibrium constant is to the power for the first equilibrium constant. So in this particular case the n value is 1 by 3. So hence we can write the new equilibrium constant for this particular reaction. So here K equilibrium dash can be written as, why? Because the first reaction is multiplied with the stoichiometric coefficient 1 by 3. So this should be equal to the K equilibrium power 1 by 3. Anyhow, the K equilibrium value is given in the question, that is 2.7 into 10 power minus 5, and this is whole power 1 by 3. And this we can write here, 2.7 can be written as 27 into 10 power minus 6, and this is whole power 1 by 3. Now if we simplify this one, we are going to get 27 power 1 by 3 means that is 3, and 10 power minus 6 whole power 1 by 3 means that is 10 power minus 2. Hence for this question the answer is D, 3 into 10 power minus 2. So this is a very simple question coming from the topic of chemical equilibrium. And we will see some other questions here. The next question, and here the subject. means it has a 4 unpaired electrons. So in case of 4 unpaired electrons, again 4 into 4 plus 2, so 4 into 6, 24. So that is the P. So here 1 should be the Q, 2 is R, 3 is and 4 P. So here it is the first option. It is also mostly direct question from the D block elements. Just you have to identify the number of unpaired electrons in the given ions and the corresponding spin only magnetic moment. So next we will see other question from the same session. We'll continue the second question, and this question is from the topic of chemical kinetics. Here the given the reaction follows the first order reaction, that is A gives rise to B plus C, and we have to identify the fraction of molecule dissociated in time t. Okay, na? And first order reaction, let us take the reaction is like this. The reactant A gives rise to the products B plus C, and let me take at a time t equal to 0 the amount of reactant, let us assume A0, after some time t the amount of reactant left, that is AT, and from this the amount of reactant reacted, how much it is? It is initial amount minus the final amount of reactant reacted, that is equals to the initial amount minus the final amount. So now we have to identify the fraction of molecule dissociated. So amount of the fraction means what here? The fraction of molecule dissociated means the amount of the reactant reacted by the initial amount. So fraction of molecules, here amount we can take, fraction of molecules reacted or dissociated, that is equals to amount of the reactant reacted, that is A0 minus 18, and initial amount anyhow this is A0, and from this we can write this is 1 minus AT by, this is 1 minus AT by A0. And also we know that from the first order kinetics, the ratio of the amount of reactant left after some time, the amount of reactant taken initially, that is equals to e power minus kt, and this AT by A0 value if you substitute here, we are going to get 1 minus e power minus kt. So this is the fraction of molecule dissociated. Actually this question also asked in the previous means, long back. So again is the kind of repeated question we can say. So here the option is first option, 1 minus e power minus kt. So likewise we will see some other question, and here this is a question from D block elements, and they gave the metal ions the corresponding magnetic moments in terms of Bohr magnetons we have to identify, and the formula for Bohr magnetons. So we have the spin only magnetic moments mu is equals to It is a root over n into n plus 2 Bohr magnetons. Here where n is the number of unpaired electrons. So we have to identify the number of unpaired electrons in each metal ion in the given column 1. So let me go with the manganese 2 plus. If you see the electronic configuration for manganese 2 plus, and this is a argon 3d5 and 4s0. So 3d5 means what? It has a 5 unpaired electrons. So if n is equal to 5, if you substitute there, we are going to get this is a 5 into 7, this is a 35. So it is a 35, means the first one should be option Q. And similarly, cobalt 2 plus, if you see the ion configuration, cobalt 2 plus configuration, and it is the argon 3d7 4s0. So 3d7 means what? It has a 3 unpaired electrons. So again, in place of n, we can write 3. 3 into 3 plus 2, 5. 3 into 5, it is a 15. So 15 is there. So option 2 should be R. And similarly, copper 2 plus, the electronic configuration of copper 2 plus, if you see, it is a argon 3d9 4s0. 3d9 configuration means what? It has a 1 unpaired electron. So in place of 1 n, if you put 1, and we are going to get root 3. So third one is S. Similarly, last one chromium 2 plus, the electronic configuration of chromium 2 plus is again it is a argon 3d4 and 4s0. 3d4 means it has a 4 unpaired electrons. So where n is equal to 4, so 4 into 6 24. The last one is also came already, and this is P. So here among the 4 options, if you see, and this is actually option B, option C, D. Here one is Q, 2 R, 3 S, 4 B. So this is option 1. Here option 1 is the correct option. And similarly, we will see some other memory based question. And here a statement type of question here, and they give the 3 statements. Consider the statements. In the statement 1, actinide contraction is greater than the lanthanide contraction, and say statement 2, terbium 4 plus and cerium 4 plus, and they are mentioned that they are oxidants, means oxidizing agents. And similarly statement 3, ytterbium 2 plus and europium 2 plus, and both are given as reductants. So here we have to identify, so which are the correct statements. See here all are correct statements only. Generally actinide contraction is higher than the lanthanide contraction. Why? So actinide contraction case we have involvement of 5s orbitals are there. In case of lanthanide contraction there is involvement of 4f orbitals. And we know that and 5f orbitals are having more poor shielding effect than the 4f orbitals. So higher the poor shielding effect, ultimately more contraction in their size. So ultimately the nucleus can strongly pull the valence electron effectively if the intervening electrons cannot stop the force of the nucleus. So hence in this particular case actinide contraction is higher than the lanthanide contraction. Since the statement 1 is correct. Similarly statement 2, so terbium, normally here lanthanides common oxidation state is +3, but here they are more than +3, +4 oxidation state, and they are trying to convert it to +3 oxidation state. Here the ions are coming from higher oxidation state to lower oxidation state. Hence these acts as oxidizing agents, and this is also correct statement. Similarly, if you see statement 3, ytterbium 2 plus, europium 2 plus, again their common oxidation state is +3, and in this particular case they are trying to convert they are going to increase their oxidation states from +2 to +3. So in this particular case their oxidation state is going to be increases. So hence they act as a reducing agents. So hence this is also correct. So here all these 3 statements are correct. So this is from F black elements. So in previous question that is from D black elements, and this was from F black elements. This is also very easy question, you can say. And next question we will see here. The calculated spin-only magnetic moment of 2 complexes are given here. The potassium hydroxide of iron and ferrate, and second one potassium hexahydroxide of ferrate. And first case the oxidation state of iron is 3, and second case the oxidation state of iron is 2. Here the iron oxidation state is 3, and here the iron oxidation state is 2. Now we have to identify the spin only magnetic moment again, and this is the question from the coordination compounds. And here, so iron 3 plus, in iron plus 3 oxidation state. Again the ligand present here OH minus, this is a weak field ligand. Here OH minus is a weak field ligand. So in case of weak field ligand, there is no pairing of electrons. So for iron 3 plus, the electronic configuration is, again this is the argon 3d5 4s0. So 3d5 means there is no pairing of electrons, all are unpaired electrons only here. So we have 5 unpaired electrons. 5 unpaired electrons means the spin only magnetic moments, mu value should be 5.92 Bohr magnetons. And similarly, if you see the second complex, and where the iron oxidation state is +2 and its electronic configuration iron 2 plus, this is argon 3d6 4s0. So 3d6 again the OH only ligand. So again this is a weak field ligand, no pairing of electrons. In case of 3d6 configuration, we have 4 unpaired electrons. If there are 4 unpaired electrons, the mu value is 4.90 Bohr magnetons. So here hence the option is for first complex 5.92, for second complex is 4.90. So overall it is the first option. And similarly we can see some other questions here. And this is a question from redox reactions, the concept of law of equivalence. See here the question is given like this: the number of moles of ferrous oxalate and ferrous sulfate ammonium sulfate .6, this is a Morse salt required to completely react with 2 moles of the acidified KMnO4 for each of them is respectively. Here we have to take acidified KMnO4. So in this particular case, we can use the law of equivalence. According to law of equivalence, the gram equivalence of ferrous oxalate should be equal to what? Gram equivalence of KMnO4. Here no need to balance the reaction, just we can take the equivalence of ferrous oxalate is equal to equivalence of potassium permanganate in acidic medium. So here gram equivalence, your question they are asking in terms of number of moles. So you can convert the gram equivalence in terms of moles, that is number of moles of the particular substance into its n factor, that is for in this particular case ferrous oxalate. And similarly the gram equivalence of KMnO4, again this is number of moles into n factor of KMnO4. So what are the number of moles we have to identify for ferrous oxalate, and again what is the n factor for ferrous oxalate? So ferrous oxalate n factor is 3. Then how to identify the n factor for ferrous oxalate? Here you can see the ferrous oxalate here. So it will oxidizes in presence of KMnO4. Why? Because KMnO4 is a strong oxidizing agent. It can oxidize the ferrous oxalate too. So in a ferrous oxalate iron, it is in +2 oxidation state, and that will be oxidized to +3. And similarly we have the oxalate is oxidized to carbon dioxide, and here carbon oxidation state is +3 and oxygen is -2. And here there is no change with respect to oxidation state of oxygen. Only iron and carbon, both the elements, their oxidation states are going to be increases. Here iron oxidation state is changing from +2 to +3, and whereas carbon oxidation state is changing from +3 to +4. Now we have to identify the total change in oxidation state with respect to iron. And so this is this Fe, F2 gave here, it is Fe. Sorry, this is not 2, it is an Fe. So here 1 iron +2 to +3. So with respect to iron, the change in oxidation state is 1. Similarly with respect to carbon, so +3 to +4. So actually here there are 2 carbons are there in this molecule. So per each carbon 1 is oxidation state. For 2 carbon the total oxidation state change is 2. So overall oxidation state change with respect to iron and with respect to carbon is 3. So hence the n factor for ferrous oxalate is 3. So here and this is Fe. I wrote 2 here, and this is actually Fe, FeC2O4, and that is equals to, again, the number of moles of KMnO4, and here it is given in the question, that is 2 moles, 2 into, and what is the N factor for KMnO4 in acidic medium? KMnO4 N factor is 5. So now N is equals to 10 by 3. 10 by 3 means it is 3.33 moles. And in a similar way, we have to identify for Morse salt. In case of Morse salt, here iron +2 oxidation state and sulfur is in +6 oxidation state. So sulfur, it won't be oxidized further in presence of KMnO4. Only there is a chance to undergo oxidation with respect to ferrous ion only. So here only ferrous ion is converted to ferric ion. Now overall, and similarly the gram equivalence of Morse salt, and here FeSO4 ammonium sulfate dot 6H2O, and this value should be is equal to similarly the gram equivalence of KMnO4. And if you see here, and in this particular case in the Morse salt, only one iron in +2 oxidation state is changed to +3 oxidation state. So N factor for ferrous ammonium sulfate is 1 only. So number of moles into its N factor is 1, and similarly for KMnO4, as usual, it is number of moles is given 2 and N factor is 5. So then N is equal to 10. So in case of ferrous ammonium sulfate is a Morse salt, the number of moles required is 10, and in case of ferrous oxalate it is 3.3. Hence it is the first option, 3.33 and 10 moles respectively. So next we will see other question, and this is a organic question, and this question from the topic nitrogen containing compounds. And here we will see first, nitrobenzene is undergoes several reactions. First, nitrobenzene is treated with tin HCl, and tin HCl, it acts as a reducing agent, hence it can reduce nitro group to NH2 groups. Here nitrobenzene is converted to aniline, and this is the first step when we will use the tin and HCl. And in the second step, and we are going to use here bromine water. When aniline will treat with the bromine water, here NH2 is a strongly activating group, hence tribromo derivative we are going to get. All the positions here NH2 can activate ortho and para positions, 2 ortho positions, 1 para position, hence we are going to get a tribromo aniline. So here 2 ortho positions and para positions are occupied by the bromine, and that compound further treated with, and here NaNO to HCl. So here diazotization process, and NH2 is converted to diazonium ion when we treat with this NaNO to HCl mixture. The remaining the positions of bromine will not affect, and next, and this compound further, and they treated with ethanol. So when this diazonium salt, when you treat with either ethanol or H3PO2, and that can simply convert the diazonium ion to benzene. Here N2 is going to be released, and straight away we are going to get a benzene compound. The remaining groups, the bromine groups, they will not be influenced, and they are remains same, and that we are going to get tribromobenzene, and apart from that nitrogen gas is going to be released, and this ethanol is converted to, that part is oxidized to acetic acid. So in the question they are asking A and B, and what is identify the A, that is benzenide product. So here the benzenide product is a tribromobenzene only. So hence in the options, so it should be the second option, it is a tribromobenzene. And we can see the next question. So yes, we can stop here. These are the questions so far we received from the memory based questions, and next we will continue the remaining questions after getting. Thank you.
inputs of A and B are given. Find out result Y of the circuit. So here this is a NOT gate. So when the input A is given to NOT gate, it becomes A bar here, and A bar and B are inputs for the NAND gate. This is NAND gate. This one is NAND gate. So it becomes A bar and B bar. So this is the output Y. So this is equal to A or B bar. So this is the output. So option 1 is correct. Next, let us see the second question. A uniform sphere of mass m and radius r is divided into two equal parts. One part of sphere has moment of inertia I1 about diameter, and moment of inertia of disk of radius 2r and mass m about perpendicular axis through its center is I2. Find I2 by 1. First, let us find moment of inertia of hemisphere. For complete sphere about this diameter, moment of inertia 2 by 5 m r square. If you cut this into two equal parts, so if you cut this into two equal parts, if you see one hemisphere about the same diameter, moment of inertia becomes half of the initial value, that is 2 by 5 m r square. Half of 2 by 5 m r square, this is m r square by 5. So if you come to the case of uniform disk, this is disk about this axis passing through center and perpendicular to its plane. Its moment of inertia I2 is m r square by 2. Actually, in place of r we have to write 2r because radius given 2r. So this is 2m r square. So therefore I2 by I1 becomes I2 by I1 equal to, this is 2m r square, this is 2m r square by m r square by 5. So this is so I2 is 2m r square by I1 is m r square by 5. So this becomes 10. This m r square we can cancel. So the answer is 10. So if you see the next question, a system of two composite wires is having a mass of 8 kg attached with it as shown in figure. Wire 1, for wire 1, y1 Young's modulus given, radius given. Radius R1 is 2 mm, its length 0.314 meter. And for wire 2, Young's modulus given as 4 in 10 power 11, radius 2 millimeter and length 0.628 meter. Find total extension in the wires. So here if you see in this wire and in this wire, tension is same and the tension is 8G, that is 80 Newton. The tension is 80 Newton. So here what is the extension in the upper wire B E1 and extension in the lower wire B E2, then total extension is E1 plus E2. And we know E is FL by AY, that is F L1 by A Y1. Here F L2 by A Y2. So here we can take F common. So this is A1, this is A2. So E1 is FL1 by A1 Y1, E2 is FL2 by A2 Y2. We can take F common, and this is L1 by pi R1 square Y1 plus L2 by pi R2 square Y2. So it will come like this. Then this E equal to, so F is 80. Let us substitute this. L1 is 0.314 meter, which is pi by 10. By area, pi R1 square. Pi R1 is 2 mm, so 4 into 10 power minus 6. This is into Y1 is 2 into 10 power 11. 2 into 10 power 11 plus L2 is 2 pi by 10, because L2 is given as 0.628 meter. We can write it as 2 pi by 10 into 1 by pi R2 square, again 4 into 10 power minus 6 into Y2 is 4 into 10 power 11. So here we can cancel pi, here also pi, here 2 times, and this is 80, and here in the first term 10 power minus 6 into 10 power 11, that is 10 power 5. When it goes to numerator, it becomes 10 power minus 5. And here this is 4 to 80. This is 1 by 80 into 10 power minus 5, you can write. And here in the second term, 2 4 8 into 10, this is 1 by 80 again into 10 power minus 5. So it becomes 80, you can cancel, and this is 2 into 10 power minus 5. So the answer is third option. So 2 into 10 power minus 5 meter is the total extension in the two wires together. Okay, next let us see the next question. So there are two samples of gases. Sample A, number of moles is 2 and volume is 3V0. Sample B, number of moles is 2 and volume is V0. If relation between pressure and volume for both samples is P equal to P0 by 1 plus V by V0 whole square, then find difference between temperatures of sample B and sample A. Okay. So for sample A, if you take volume, number of moles is for A, number of moles N equal to 2, volume 3V0. Next V, this is this volume V equal to 3V0, volume V equal to 3V0. V equal to 3V0. So then what is pressure for that? Pressure for A is, if you substitute in the formula, P equal to P0 by 1 plus V by V0 whole square. So in that, if you substitute, V is 3V0 by V0 whole square, then this becomes P0 by, so V0 gets cancelled, 1 plus 3 square 9, this is 10. So pressure is P0 by 10. Then from PV equal to nRT, PV equal to nRT. Then what is temperature of this gas one? T1 equal to PV by NR. PV by NR. P is P naught by 10 into volume is 3V naught by N 2 moles to R. So this is 3 P naught V naught 3 P naught V naught by 20 R. This is T1. So similarly for B, if you take for B N number of moles 2, volume is V naught, then pressure becomes P naught by 1 plus this is V naught by V naught whole square. So this is V naught by V naught is 1. So this is P naught by 2. This is pressure. So from PV equal to nRT again. T2 temperature of this is PV by nR. This is P is P by 2, P naught by 2. V is V naught by N 2 moles is the R. So this is P naught V naught by 4R. This is P naught V naught by 4R. This is T2. Then what is T1 minus T2? So this is actually you can write this as 5 P naught V naught by T2 we can write as 5 P naught V naught by 20R. So T2 minus T1 is 5 P naught V naught by 20R minus 3 P naught V naught by 20R. This is 2 P naught V naught by 20R. So P naught V naught by 10R. This is a temperature difference. So the correct option is option 1. So next let us move to the next question. So a spiral coil having total 200 turns, inner radius 3 centimeter and outer radius 6 centimeter, and it has 20 milliampere current through it. Find its magnetic moment. Okay, if you see this spiral coil like this, okay, let us draw this again. So this is a spiral coil like this. So here the inner radius of this is R1 and the outer radius of this is R2. Okay, here the total number of turns in it 200. Let it be capital N. So what is the width of this? This width is R2 minus R1. For R2 minus R1 width, number of turns N. For unit width, number of turns N by R2 minus R1. These are the number of turns in unit width. So to find magnetic moment of this spiral, so let us take a strip here. Let us take a strip. This is a strip. Let us take a strip of radius R and width dr in this. r be the radius of this, and width of this strip is dr. This is dr, that is width of that strip. Then what are the number of turns in that width dr? So n by n2 minus r2 minus r1, this is n by r2 minus r1 in this width dr, number of turns n by r2 minus r1 into dr. So these are the number of turns in this circular strip. So we can take this as a coil having n number of turns, where n is this n by capital N by r2 minus r1 into dr. Okay. So then what is magnetic moment of this circular coil? M dm equal to, say, small amount of that magnetic moment equal to IA, N IA. N is capital N by R2 minus R1 into dr. These are the number of turns into current into area pi r square, area bounded by that coil. Then it becomes n pi I by r2 minus r1 into r square dr. Then what is the total magnetic moment of this coil? M equal to integral dm, that is integral n pi I by r2 minus r1 into r square dr, and we are integrating it from r1 to r2, that is r is changing from r1 to r2. So this is n pi I by r2 minus r1 into, this is r square by, this is r cube by 3, r cube by 3, limits r1 to r2. So this becomes n pi I by r2 minus r1 into, this is r2 cube minus r1 cube by 3. So this is the total magnetic moment, and if we substitute that here, so m equal to, so m equal to, n is 200, given 200 turns, this is pi into I is 20 milliampere, 20 into 10 power minus 3 by R2 minus R1. R2 is 6 centimeter, R1 3 centimeter. So difference 3. 3 into 10 power minus 2, converting into meters. And this is R2 cubes. 6 cube is 216 minus 3 cube 27, and converting this into meters into 10 power minus 6. Centimeters 10 power minus 2, whole cube is 10 power minus 6. This by 3. So this is 4 into 10 cube. This is 4 into 10 cube here into pi into 10 power minus 3 here into 10 power, this is 189 into 10 power minus 6 by 3 by 3 into 10 power minus 2. So this becomes this is a 9 twos 9 21 into 4, this is 84 pi, this gets cancelled, and this is 10 power minus 4 is remaining into 10 power minus 4 ampere meter square. So the answer is 84 pi into 10 power minus 4. So third option is correct. So coming to the next question, let A minus 2 minus 34 6 and lines L1 x minus 1 by 2 is equal to y minus 4 by 4 is equal to z minus 0 by 1, and L2 x minus 2 by 1 is equal to y plus 2 by minus 4 is equal to z plus 2 by 3. We want the distance of A from L2 measured along L1. So here this is the line, this is the line L2. We want distance of A, here is A minus 2 minus 34 6, and we have to find out the distance of A from L2. This is measured along L1, this is L1. That means the line joining AB is parallel to L1. That's why drs of AB same as drs of L1. So now equation of AB, equation of AB, it is passing through minus 2 minus 34 6 and having drs 2 4 1, they are the drs of L1. That's why its equation is x plus 2 by 2 is equal to y plus 34 by 4 is equal to z minus 6 by 1. Now we want distance between A and B, that is the distance of A from L2, that is measured along L1. To find the coordinates of B, here B is nothing but intersection of AB and L2, intersection of AB and L2. Now if you take this is lambda, then the coordinates of B become 2 lambda minus 2, 4 lambda minus 34, lambda plus 6, and B is also point on L2. So take this is L2 equation, x minus 2 by 1 is equal to y plus 2 by minus 4 is equal to z plus 2 by 3. So let it be mu, then coordinates of B, mu plus 2 minus 4 mu minus 2, 3 mu minus 2. Now equating x coordinates and y coordinates on both sides, we get these three equations. Solving 1 and 2, we get lambda and mu values, and that satisfies the third one. That lambda value after solving these two is 4 and mu is also 4. Now substitute this lambda here or mu here, both will give the point B only. So now coordinates of B is 2 lambda minus 2, lambda 4 na? So 2 lambda minus 2 becomes 6, and 4 lambda minus 34, 16 minus 34, that is minus 18, and lambda plus 6, lambda is 4, 4 plus 6 is 10. Now the required distance is AB, distance between A and B, that is square root of minus 2 minus 6 whole square plus minus 34 plus 18 whole square, that is 16 square, and 6 minus 10 whole square, that is 16. So you can take 16 common. It is 4 plus 16 plus 1 under root. So this is 4 root 21. So the distance of A from L2, that is measured along L1, is 4 root 21. That is option 2 correct here. Now coming to the next question. Given S set of all A, where A is a square matrix ABCD, the elements of ABCD are from the set 0, 1, 2, 3, 4, and satisfying A square minus 4A plus 3I is equal to null matrix. We want number of elements in the set A. This A square minus 4A plus 3I is equal to 0 is the characteristic equation of the set A ABCD. That's why trace of A is 4 and det A is 3. This A square minus 4A plus 3I is equal to 0 is characteristic equation of A. So that's why this 4 is the trace of A and this 3 is determinant of A. And we know trace of A is A plus D, sum of the elements in the principal diagonal, that is 4, and det A is AD minus BC, that is 3. Now we want possible ABCD values satisfying these two equations, and ABCD are selected from this set 0, 1, 2, 3, 4. Now this is A, this is D. So possible AD, so that A plus D is 4, is 0, 4, 1, 3, 2, 2, 3, 1, 4, 0. Last possibility. A plus D 4, the possible A plus D 0, 4, 1, 3, 2, 2, 3, 1. Now, if A plus D is 4, taking A is 0 and D is 4, AD becomes 0. So from that we get BC product, that is minus 3. Similarly, if you take the second set as AD, then this product AD become 3, BC is 0. If A and D are 2 and 2, product AD become 4 and BC is 4 minus 3, that is 1. Similarly, if A is 3, D is 1, AD become 3 and BC 0, and A 4, D 0, then AD becomes 0, so BC is minus 3. But according to the elements in that set 0, 1, 2, 3, 4, BC minus 3 not possible, because no value of BC in this set whose product is minus 3 not possible. So now the possible BC, so that BC product 0. So BC product 0 na, so I am taking B0, C is 0, 1, 2, 3, 4. So total you get 5 combinations here. What are that? 0, 0, 0, 1, 0, 2, 0, 3, 0, 4. Similarly, take C0 and the possible combinations of B is 1, 2, 3, 4, because already 0, 0 is there here. So total here 5, here 4, total 9 combinations you get in this case. Next, coming to AD 2 to BC product 1. So possible BC is 1, 1 only. So there is only one possibility here. Similarly, BC 0. Again, this number of combinations here we get. B0, C is any of 0, 1, 2, 3, 4, and this is 1, 2, 3, 4, and this is 0. Here also you get 9 possibilities. Total 9 plus 1 plus 9. So required number of elements in the set S. So number of elements in S is 9 plus 1 plus 9, that is 18. Sorry, 19. 9 plus 9, 18 plus 1, 19. Second option. So for this you must know, if A square minus Ka plus Mi 0, K is the trace of the matrix A and M is the determinant of A. So from that you get the relation between A, B, C, D and select A, B, C, D satisfying that relation from the set 0, 1, 2, 3, 4. So coming to the next question. A, B and C are vertices of a triangle such that A 1, 2 and midpoint of AB is 3, 4 and centroid is 5, 7. If the vertices of circumcenter of the triangle ABC is alpha beta, then 12 times alpha plus beta. Here ABC is a triangle. This is triangle ABC. Given also that A is 1, 2. This is B and this is C. And also given midpoint of AB, that is 3, 4. And given centroid, that is 5, 7. Now, we can find the vertices of B by using midpoint formula. If B is x2, y2, we have x2 plus 1 by 2 is 3, y2 plus 2 by 2 is 4. From this we get x2 5 and y2 6. Now B is 5, 6 and given centroid, that is 5, 7. If you take C is x3, y3, then 5, 6, 5, 7, that is centroid, is equal to x1 plus x2 plus x3 by 3 and y1 plus y2 plus y3 by 3. From this we can find x3, y3. So 5 is, x2 is 5 here. So 1 plus 5, 6. 6 plus x3 by 3. And 7 is, y2 is 6. So 2 plus 6, 8 plus y3 by 3. Therefore C is x3, that is 15 minus 6, 9 and y3, 7 into 3, 21 minus 8, that is 13. So C is 9, 13, B is 5, 6. Now we can find the circumcenter. Take S is the circumcenter. Say some H, K. Given it is alpha beta. So S is alpha beta. And we know SA square is equal to SB square. If S is the circumcenter, it is equidistant from the vertices of a triangle. So SA is equal to SB, squaring on both sides, we get SA square is equal to SB square. That is alpha minus 1 whole square plus beta minus 2 whole square is equal to SB square. Here B is 5, 6. Alpha minus 5 whole square plus beta minus 6 whole square. Expanding this and simplify. Alpha square, beta square, both sides get cancelled. It is minus 2 alpha plus 1 minus 4 beta plus 4 is equal to minus 10 alpha plus 25 minus 12 beta plus 36. So now it is, take minus 10 alpha this side, it is already minus 2 alpha, minus 2 alpha plus 10 alpha is 8 alpha, minus 4 beta plus 12 beta, that is 8 beta, and coming to the constant, 25 plus 36 minus 5, it is 56. Now alpha plus beta 7. Actually what do you want? 12 times alpha plus beta. that is 12 into 7, that is 84. So no need to find the total circumcenter here, because we want 12 times alpha plus beta. If you want total circumcenter, again we have to consider SB and SC equal. That will give another equation in alpha beta. Solve these two equations. One is alpha plus beta 7. Another equation obtained by equating SB and SC. We get alpha beta from that. But here no need to find the second equation, because we want 12 times alpha plus beta. That you get like this. So coming to the next question. Consider 8 observations. A, B, 8, 103, 13, 21, 67, 17, where A greater than B. If median and mean deviation about median are 21 and 26, then the value of 2A. Given 8 observations here, that is A, B, 8, 103, 13, 21, 67, 17, and also given that A greater than B. Given median of these 8 observations is 21. So to find the median of the given set of observations, first you write the observations either in ascending order or in the descending order. So if you write the known numbers in ascending order, first you get 8, next to 13, next to 17, next to 21, next to 67, next to 103. If we take BA here, because given that A greater than B, the median is the mean of these two. 21 and 67 mean is not 21, because in the question given median is 21. That's why this B you have to place here. Here is our B and here is A. Then the mean of these two is 21. That's why B is 21. Since 21 plus B by 2 is 21, that is the median. Now to find A, given that mean deviation about median, so here median, say capital M, is given 21. So mean deviation about median is sigma xi minus m modulus by total number of observations. Here it is 8. Now subtract each observation from the median and equate that to 26. So here median is 21. First 21 minus 8 modulus, next 21 minus 13, 21 minus 17, next to 21 minus 21, next also 21 minus 21, because B is 21, next 21 minus 67, and 21 minus 103 plus 21 minus A by 8. I am taking the denominator 8 to the left hand side. So 26 into 8, 26 into 8, 208, and if you simplify this, 21 minus 8, 13, 21 minus 13 is 8, and this is 4, 21 minus 21, 0, next 0, 46, 21 minus 67 modulus, this is 82 plus 21 minus A. So you will get 208 is equal to 153 plus mod of 21 minus 8, adding 13 plus 8 plus 4 plus 46 plus 82. From that we get 21 minus A is 208 minus 153, that is 55. So A is 76, possible value of A, positive value of A, that too. And we want 2A, that is 2 into 76, that is 152. The only thing difficulty here is where you have to place that B and A. given that A greater than B, if B is placed after 21, then only we get median is 21 and corresponding B value must be 21. And the rest is formula only, direct mean deviation formula. From that you get relation in A, that will give A value.
We'll discuss some more question of today's first shift paper. You can see the question is from the AC circuit. Power factor of the below circuit is 0.5. Find XL minus XC mod take root 3 is equal to 1.73. Now, as we know, power factor cos phi, we can write is equal to R by Z. Cos phi is equal to R by Z, and this is equal to 0.5. We can write 1 by 2, or we can write 2R is equal to Z, impedance of the circuit, we can write under root of R square plus XL minus XC whole square. Under root of R square plus XL minus XC whole square. If you square on both the sides, get from here 4 R square is equal to R square plus XL minus XC whole square, and from here we can write the value of XL minus XC. So XL minus XC mod, this we can write this is equal to root 3 R, given that root 3 is 1.73 into R value is 100. So you can say this is equal to 173 ohms. So option 2 is correct answer for this problem. Now the next problem, you can see it is a current electricity chapter problem, and in this, as we can see clearly, this number of cells they are connected in this circuit. And if you see little bit carefully in this one, you can see these cells are in parallel. There's a parallel connections of the cells, and in parallel connection we can write the E equivalent. So we can simplify this circuit easily. Over here I can redraw the circuit. One cell, second cell, third, fourth also we can connect here, and the two resistance here. So here we can see these four cells are in parallel. Now we can use a formula for equivalent EMF of the cell, that we can write E1 by R1 plus E2 by R2 plus E3 by R3 plus E4 by R4, this whole divided by 1 by R1 plus 1 by R2 plus 1 by R3 plus 1 by R4. And here you can see clearly all the values of E, that is same, as well as all the values of R1, R2, R3, R4, that is also same. So we can write here E, that is 27, upon small r, that is 3, and how many cells we have? 4. So this into 4 divided by 1 by R1 plus 1 by R2. If you write this, so you can write this would be 1 by 3 into 4. So this is equal to 27 volts. So equivalent EMF we have 27 volts. Now further we can calculate in this the R equivalent. So R equivalent is what? 1 by R equivalent is equal to 1 by R1 plus 1 by R2 plus 1 by R3 plus 1 by R4, and here also we can put the values. So we'll get this will be equal to 4 by 3. So R equivalent is 3 by 4 ohms. So all these cells here we can replace from a single cell. So we can draw the single cell over here. You can see here EMF 27 volts and R equivalent, that is 3 by 4 ohms. And along with this, the two 3 ohm resistance, they are in series. So for them we can write 6 ohm is R equivalent. So this point is A, this point is B. Here current I. So in the problem, what we have to find, that is a potential difference between the point AB and the current flowing in the 6 ohm resistance. So here you can see clearly this 6 ohm resistance and 3 by 4 ohm resistance, they are again in series. So I can write current I, this will be equal to 27 upon 6 plus 3 by 4. So this is equal to 27 upon 6 into 4, 24 plus 3, 27. So again this will be 27 by 4. So that is equal to 4 ampere. So this is the current which is flowing through the 6 ohm resistance. Now with the help of this current, we can also write the potential difference between the point A and B, that is I into 6. So the value of I, we have 4 into 6, so that is equal to 24 volts. So current we have 4 ampere and potential difference we have 24 volts. So you can see option 4, that is correct, 24 volt and 4 ampere current. Next question, you can see this is a electromagnetic wave question. Electric field or EM wave is given as E equal to E naught I cap plus E naught J cap plus E2 K cap sin kx plus kz minus omega t. Find reflected ray equation if theta is Brewster angle. Now as we know, in case of Brewster angle, if we draw this angle here, this is an incident ray, angle theta, this is a Brewster angle given. So we have E1 I cap, E naught J cap plus E2 K cap. So we can say this E1 I cap plus E2 K cap, if you see these two components, so this is in xz plane and perpendicular to this plane we have E naught J cap component. Now we know that if we have unpolarized light like this and it incident over here at Brewster angle, then what will happen? The reflected ray will become polarized, and in that reflected ray, which component will left? That is perpendicular to the plane. We can say this dot component. So here, if you see in the problem, E1 I cap plus E2 K cap, if these two you see, these two are in the plane, xz plane itself. So these component will be absorbed. So what will reflect here? That is E naught J cap. This component will reflect. So we can write the reflected wave equation, that is E is equal to E naught J cap into sine. Now you can see clearly here, this is x-axis and this is the z-axis. So if the ray is going in this direction, so this side will be negative z-axis. So I can write will be sine kx minus kz minus omega t. So this is the answer for the given problem. So we can say option 4, that is the correct answer. Now the next problem is, a telescope has resolving power of 5 into 10 power minus 7 radian The wavelength of light is 500 nanometer. Find diameter of telescope in Fermi meter. Now resolving power of the telescope, if we write here formula R. So this formula is what? This is equal to D aperture diameter divided by 1.22 lambda. So we know the R value, we know the lambda value, we can directly calculate the value of D. This is direct formula based problem, easily we can solve it. So R, that is 5 into 10 to the power minus 7 into 1.22 into 500 into 10 to the power minus 9. So if we solve this one, we get 305 into 10 to the power minus 15 meter. So we can say 305 Fermi. So that is the answer of this problem. So we can say option 4, that is the correct answer. The next problem is related to the work done. You can see here two forces F1 and F2 acts simultaneously of a body. F1 is equal to 3i cap plus 5j cap and F2 2i cap minus 4j cap plus 2k cap, and a body is displaced by 25 meter along 3i cap minus 4j cap. Find work done by net force. So first we can calculate the net force here. F, this will be equal to F1 plus F2, that is 3i cap plus 5j cap plus 2i cap minus 4j cap plus 2k cap. So 3 plus 2, 5i cap, 5j cap minus 4j cap, so that is plus j cap plus 2k cap. So this is the force acting on the system, net force. Now displacement is given 25 meter along 3i cap minus 4j cap. This is the direction. So how to write displacement vector here? We can write S vector. This will be equal to magnitude, that is 25, into unit vector in the direction of 3i cap minus 4j cap. So this divided by 5 meter is the displacement vector. Now we can calculate the work done easily because force is constant. So for constant force, work done, we can write directly F dot S. So we can take the dot product of these two. So here we can write 5 into 3, 15, j minus 4j cap. So minus 4, here 2 into 0. So 15 minus 4 into 25 by 5. So we can write here 11 into 5 is equal to 55 joules. So we can say this is the answer for this. So option 1, you can see that is the correct answer for this problem. Now in the question it is given that in single slit diffraction, distance between the third minima and first minima is, we have to find the distance between these two minima, location on the screen, and A is a slit width, capital D distance of the screen from the slit, and lambda is the wavelength. So if we consider this situation here, this is a screen, let us say this is a single slit. So from here, these two position, let us say this is y1 and this is y3, the position of first and third minima on the screen. So for minima in general, what we can write, that is yn is equal to n capital D lambda by A, that is the location of nth minima on the screen. So y1, that is equal to D lambda by A, and y3, that is 3 capital D lambda by A. So we can write the separation between those two delta y, that is equal to y3 minus y1, which you have to find here. So this will comes out 2 capital D lambda by A. So we can see here option 3, that is a correct answer for this problem.
Bulk modulus of water is 2.2 into 10 power 9 Pascal. At depth 220 meter, find percentage change in density with respect to density at the surface. Suppose if you take water and if you go deep into water, density goes on increasing. You consider a layer of water here at depth h. Let dH be the thickness of this layer considered, and rho naught be the density of water at the surface, and rho be the density at depth h. Then as the upper water column, as this water column applies pressure, so this liquid gets compressed and density increases. So from formula of bulk modulus, B equal to delta P by minus delta V by V. So from that minus delta V by V equal to delta P by P, where delta P is change in pressure in that layer of thickness dH. So here in this layer mass fixed, so as density rho equal to m by v, that implies rho is directly proportional to, inversely proportional to volume. That implies delta rho by rho equal to minus 1 into delta V by V. So this is nothing but delta rho by rho, fractional change in density. This is equal to, from this you can substitute minus delta V by V as delta P by B. So here this delta P is change in pressure. This is nothing but dH rho G by B. So that implies delta rho by rho square. You take this rho here equal to G dH by B. So integrating on both sides, integral of delta rho by rho square equal to G dH by B. Here integral 0 to h, and this is rho naught to rho. So at the surface density rho naught, and at depth h density is rho. So that implies minus 1 by rho. Here this is rho power minus 2, integrating that minus 1 by rho naught to rho, that is equal to GH by B. Here h 0 to h, after substituting the limits, is coming like this, or you can put like this 0 to h. So that implies so you can write it here, that implies 1 by rho minus 1 by rho naught equal to, taking this negative sign to the right hand side, minus GH by B. So that implies 1 by rho naught that is 1 by rho equal to 1 by rho naught minus GH by B. So simplifying this, 1 by rho equal to B minus rho naught GH by rho naught B. So this is rho equal to rho naught B by B minus rho naught GH. So this I can write rho naught by 1 minus rho naught GH by B. So that is variation of density, rho equal to rho naught by 1 minus rho naught GH by B, and we have to find the percentage change for that. So rho by rho naught equal to, I can write this is 1 by 1 minus rho naught GH by B. So this becomes nearly 1 plus rho naught GH by B. So as this quantity is very less when compared to 1. So this becomes rho by rho naught minus 1 equal to rho naught GH by B. So that implies rho minus rho naught by rho naught equal to rho naught GH by B. So this is nothing but delta rho by rho naught equal to rho naught square, you can write rho naught square, delta rho naught by rho naught equal to rho naught GH by B, delta rho by rho naught. So that implies percentage change delta rho by rho naught into 100, that is equal to rho naught GH by B into 100. So this is nothing but rho naught 10 cube, density of water, G10 you can take, H 220 meter, this is into 100 by bulk modulus 2.2 into 10 power 9 given. So here 2.2 100 times, then this is in the numerator, this is 4 10 power 8, and this is finally 10 power minus 1. 10 power 8 in the numerator, 10 power 9 in the denominator. Finally this, that is 0.1%. So the option 1 is correct. Next, let us see the next question. So if resistance of diode in forward bias is 10 ohm, then time constant of the circuit would be. If resistance of diode in forward bias, here this is the flow of current when the switch is closed, then this will be forward biased, this is plus minus, this is minus plus, this is reverse biased, it won't allow current flow. So then current flows, that flows in this path. So time constant tau equal to C into effective resistance in series with C, that is 2 into 10 power minus 6 to resistance 100 plus 10, 110. This is for 20 to 2 into 11. So 22 into 10 power minus 5. So capacity is 2 into 10 power minus 6. R is here 110, 100 plus 10. So total 110. So 2 into 11, 22 into 10 power minus 5. This is a seconds time constant. So alpha will be 22. Next, if range of projectile 1 is n times range of projectile 2, then the value of root 3 n is. So what is range of this projectile 1? R1 is root 3 times R2, given that. R1 u square, that is 24 square So R1 U square, U1 square sin 2 theta 1 by G. This is root 3 times U2 square sin 2 into theta 2 by G. So G you can cancel. U1 square is 24 square to sin 2 into 15 sin 30. This is 1 by 2. This is root 3. U2 square is 4 square. Sin 2 into 60 sin 120 is nothing but root 3 by 2. So this 2 you can cancel. So 24 square, this is 24 into 24. This is root 3 into this is n times, actually it's not root 3, this is n times, that is R1 is n times, sorry. So this is R1, this is n times, this is n times, not root 3 times, this is n. So here also this is n into, this is 4 into 4 into root 3. So here we have to find n root 3 value. This is 4 6 times, here 4 6 times. So n root 3 value is 36. So finally we should get n root 3 value. This is 36. Thank you.
Hello everyone, welcome back to the Narayana Group of Educational Institutions. I'm Deep Jyoti, and as you all know that we are running a series of JEE Main question paper discussion, and for that we are gathered here to discuss the question paper of 4th January 2026 Shift 1. We'll begin with mathematics, and as you can see here that we have the question papers, and this question paper is of course the memory based questions. And to discuss the mathematics question, we have our very famous Prasad sir with us. Welcome sir. Alright, so when you saw the question paper first, what is your reaction to it?
Actually, compared to previous session on JEE January session, these papers, today's shift 1 paper is comfortable to the students.
Okay.
Some of the questions are direct formula based questions there, some are tricky questions there, but on an average the paper is difficulty level average only,
Average.
not that much difficult, but some of the questions are lengthy. Actually, whenever mains paper is concerned, Most of the time it is lengthy only,
Right.
but compared to January session, it is comfortable to the students.
All right. So now that the students have completed their syllabus, it is being the question paper is not that lengthy and it's very comfortable and average, right, on the terms of difficulty.
Actually,
All right. Yeah.
students are January to April comparison. Already they are completing their board exams
Right,
also.
right.
So that's why it's favorable to the students.
It's favorable to the students.
Because
Correct,
they are
correct.
completing some more portion compared to January.
January, right?
So
Absolutely.
that's why it is favorable to the
It
students.
is favorable to the students. All right. So, sir, let us dig into each questions. Let's start with question number 1.
Question number 1 is from the functions chapter. It is direct formula based question only. So if you know number of functions and number of onto functions formula, then you can answer this. Just substitute the terms given in the formula, that will give the answer.
Easy question.
Easy
All right.
question.
Okay.
And less time taking.
Less time taking also. All right. So the mathematics paper is not as lengthy as we expect NTA to make. All right. Let's go to question number 2, sir.
It is from the complex numbers. It is geometrical application of complex numbers.
Yeah.
If you know geometry related to complex numbers well, it is easy. Otherwise, if a student do taking z as x plus iy and substituting and all that, lengthy simplification, it takes time.
Okay.
But if the student knows what z plus mod z plus 2 is equal to mod z minus 2 geometrically, and argument of z minus 3 by z plus I is equal to pi by 4 geometrically, if he knows that part, geometrical application of complex numbers, then its question is simple.
Its question is simple.
If you go with algebraic, like taking z as x plus 7 and simplify, it takes lengthy calculation.
It goes to a lengthy calculation. So what do you think? Will our Narayana students be able to solve this question?
Most of the Narayana students do this question because most of the questions that are framing for exams, whatever you conducted,
GTMs, yeah.
GTMs, this type of questions are all there.
All there, all right. So basically the question can be difficult if the student is not Narayana, but for Narayanites, it is going to be a cakewalk. All right, let's go to question number 3, sir.
It is from matrices and determinants. It is based on the properties of determinants of adjoint and determinant of a relation. It is actually a regular question only.
Regular question, all right.
So students can do this one if you know the direct formulas.
Okay, all right. Let's go to question number 4.
Question number 4 is very simple question. It's a fundamental from the permutation, from permutations and combination.
Yes.
I think every student, even the below average student, also can answer this question.
Answer this question. All right. Okay, so question number 5.
Question number 5 is from the differentiation.
Yes.
So if you know conversion of inverse trigonometry by taking substitutions and simplified techniques, then it is very easy.
Easy.
If a student start differentiating this and substituting x1, it is very difficult.
Difficult. All right.
If you know a simple technique, then you can answer this easily.
All right. Question number 6, sir.
Question number 6 is a little bit difficult compared to that remaining 5 questions.
Okay, so we have gotten one difficult question so far, yeah.
That is from the domain of inverse trigonometric functions. If you know a domain of cos inverse x and some properties of integral part of x, then you can do this question. Otherwise, for below average students, it may be a difficult question.
Yeah. All right.
Our Narayana students can do this one.
Our Narayana students can do it, yeah. We don't care about the other students. For Narayana, it was going to be a cakewalk. All right. Question number 7, sir.
It is from progressions, arithmetic progression. Actually, data is simple, but calculation part is lengthy.
Okay.
If a student do this question in a technical manner, that means calculation part in a technical manner, then he gets answer in a simple manner. Otherwise, you have to do so many
lengthy calculation. All right.
Formula and everything is simple.
Calculation is lengthy. All right. Question number 8, sir.
Question number 8 is from the definite integration and also properties of definite integrations. So if you know the properties of definite integration, students can do this question, no problem.
All right. Question number 9.
It is from the trigonometry. It is a regular question. In most of our Narayana papers, so this question is repeated so many times.
Yeah.
Not exactly that form, but
again, similar way. Yeah. All right. Okay. So now it's high time to go to question number 10.
It is from circles.
Yeah.
This is a little bit difficult one.
Okay.
But this type of models already we discussed in GTMs, not in the circle. We discussed this in other conic sections also.
Okay, okay.
So this is okay. The students, average students can do this one.
All right. Question 11, sir.
11 is from the polynomials and also functional equations related question. Some of the students feel difficult to do this question, but merit students can do this. So this is also one of the difficult question among these questions.
Okay, okay. So we have gotten 2 to 3 difficult questions so far. All right. Question number 12, sir.
Question number 12 is a regular one.
Okay.
From 3D geometry, most of the time, whatever the questions that are repeated, same models are repeated, just numerical changes only.
Correct.
So most of the students can do this question, no problem.
Right, right, right. Even also, I am also getting the faint memory of this sort of questions. Yeah. All right. Question number 13.
It is from matrices and determinants and also permutations combination application. It is a multi-conceptual question. But those who knows about characteristic equation and all that only can do this question.
Right.
Otherwise, if they don't know about characteristic equation and its properties, it goes to lengthy.
It becomes lengthy.
Otherwise, you can do that one.
All right. Question number 14.
Question number 14 is a simple question.
Okay.
Given just 3 vertices of a triangle.
Yeah.
You can find remaining 2 vertices. One vertex given, we can find remaining 2 vertices the given data.
Right.
And after that, finding circumcenter. It is direct question only.
Correct, correct. Based on formula. All right. Let's go to question number 15.
15, actually a good question. But here 2 unknowns given A, B, where you have to place B in ascending order of these numbers. If you know that thing, remaining part is simple.
Okay.
So only that part is tricky here. If you know that thing, and the rest is very simple.
So like basically you have to place B in a particular place, right? And then only this becomes easy, or else it becomes difficult. All right. So we are done with the discussion of all the 15 questions. Basically these were the memory based questions that we have gotten from our students. So when you saw the entire question paper, we discussed everything. What do you think? What is the level of this question paper on a scale of 10?
Taking difficulty level, I can give 10. Average questions, below average questions, that means easy questions. Easy questions are 50% there.
Okay.
And 20% moderate.
Okay.
30% difficult.
30% difficult. All right. That's pretty good. Like it's like overall, how is the question paper? Moderate, easy, difficult?
It is student friendly question.
Student friendly question paper?
Yeah.
All right.
Those who prepared well, they can answer the most of the questions in this paper.
All right. So what we used to see in general, that whenever there was a question paper released by NTA, it was always, mathematics was always supposed to be lengthy. What do you think? Whether this paper was very lengthy or how it is?
Not very lengthy. It's lengthy, but not very lengthy.
Not very lengthy.
So if student allotted a sufficient time, they can answer more number of questions in this paper.
All right. All right. Sir, okay. Now since we have done the discussion, one piece of advice that you would like to give for the students who are going to appear for the upcoming shifts.
So only thing, first of all the students get confident on the formulas first.
Right.
Whatever the questions that are direct from the formulas, you are in a position to answer that. So first of all, every student must perfect with the formulas, and whatever the model questions that are coming in the last January session, you practice those models only, because similar models are repeating here.
Right.
So that's my advice to the students.
All right. So basically practice the questions from the previous models and remember all the formulas. With that, we are done with the mathematics part. Thank you so much, sir, for being with us. Thank you. For chemistry, we have our very favorite Neha ma'am. Welcome, ma'am.
Thank you. Thank you.
Yeah. Ma'am, when you first saw this question paper, what was your reaction to it?
I think again it is from the yesterday's morning shift, similar moderate.
Moderate.
It was moderate paper. Of course, we are commenting only based on the number of
memory-based questions.
Memory-based questions we have got. So it is moderate.
All right. Now, let's dive deep into each question. Ma'am, what is your reaction to question number 1?
First question we have is from organic, and all the 4 name reactions given in column 1 and the reagents given in column 2, all the 4 are clearly mentioned in NCERT. So, and very important for 12th boards also.
Correct, correct, correct.
So, they should have done it. This question they should have scored positively.
All right. Question number 2.
Question number 2 is simple. Though students who might be little more cautious may get confused with the word STP, because as per the new STP, this 11.2 should have been 11.35, but I think all teachers teach their students to act smart.
Right.
If they are giving 11.2, we have to go for 22.4 and should have done it.
Right.
Answer is also easily calculatable.
Okay, now let's go to question number 3.
Question number 3 is xenon, like noble gas family. Easy.
Yeah.
Just need to draw correct structure.
Correct, correct, correct.
And
correct.
nothing more.
Yeah, they are asking only the LP and BP for it. Yeah. Question number 4, ma'am.
Question number 4, I would say the first statement most of the students will do correct, because boiling point of these they remember in hydrogen bonding and all those places. Melting point, I really doubt. Those who have clearly read that table in NCERT given about the data, or may have made some important short notes, then only they would have done.
Okay.
This is a question which could be like
a little bit
problem.
trick.
Yeah.
Okay, okay. All right, let's go to question number 5, ma'am.
Question number 5 again. Usually, most of the students don't like this particular topic: biomolecules, disaccharide, reducing, non-reducing. Again, if they read it and remember the basics, except for sucrose, all the disaccharide in our syllabus are reducing.
Right.
If they remember that line, then it is very, very fast. 30 second, I don't think even 30 second will be required.
Correct, correct. Question number 6, ma'am.
Question number 6 is important question from lab manual. As we always say, also pay attention to the NCERT lab manual, which is easily downloadable from internet. Internet NCERT site.
NCERT's website, yeah.
So this is phenolphthalein question and scoreable.
Scoreable. All right. Let's go to question number 7, ma'am.
All-time favorite, atomic structure.
Yes.
I think no shift has gone without this particular topic.
Structure.
And after that, it is easy.
Yeah. Question number 8.
It is from buffer solution, ionic equilibrium, but again easy.
Easy?
Yeah, formula based.
Formula based, okay.
Right.
Question number 9.
9, if anyone could have remembered that one letter designation, then they were lucky.
Yeah.
This was last asked, if my memory doesn't, cheat me, then it was in 2019, where it was last asked single.
Okay. All right.
Single letter code.
Code of the amino acids, yeah.
Again, yesterday also in the evening shift, this type of question, this again is appearing here. And the worst part is they are not giving any loophole. Without remembering this one letter, you cannot solve the question.
Right.
Even if you remember essential and non-essential, no options are made that you have to know that single letter.
Correct.
So that would be problem.
Yeah. Question number 10.
Question number 10 is very easy. If they remember the minus I order, no problem.
All right. Question 11 now.
Question number 11 is again from, as you can see, chemical equilibrium. Easy, scoreable, not much calculative.
Okay. Question 12.
Question 12 is chemical kinetics and direct formula base, I will say.
Okay.
Scoring.
Okay. Question 13, ma'am.
A small input of time is required, as again you have to write all the electronic configuration, count the unpaired electrons, and then match with this. I won't say it is tough, it is time taking.
All right. Question 14.
D and F block, usually neglected by students, but in last 3 papers, like on 2nd of April morning, evening, and again,
right,
continuously, each paper is having one question from D and F block. So important. And the concept used are also very common.
Right.
They could do. But the major part, if you see, is a 3 statement. So it is not that key you can just go by 1 or 3 lines. You have to analyze all the 3. So time input is required.
Time input is required. All right. Let's go to question number 15 now.
Question number 15 is spin only magnetic moment. Coordination complexes. You need to know what type of configuration and all those things. Just again, on the point, invest some time, get some marks.
Right, absolutely. Now let's go to the last question. As per the memory based question, we have gotten only 16 questions.
So 16th question is basically a PYQ.
Okay.
But change the numerical data.
Oh.
It is from moderate zone, calculative. It will be, I'll not grade it as easy, level 2 type of question.
Level 2 type of questions.
Little time is important.
Time is important.
Now, with this 16, we are grading that maybe the paper is moderate. Possibly like 17 to 25.
Yeah.
You never know. Maybe the tough questions are in
there in the questions which we didn't get from the memory.
Yes, because with this till 16, it seems to be a moderate
question paper. All right. Now, if I ask you to rate this question paper on the basis of the 6 questions that we received, how would you rate it on a scale of 10?
7.5 again.
7 to 7.5.
Yes.
So you're not very much satisfied with the NEP this time?
No. NTA is not doing their work. Or rather, I should say it is quite an injustice to January aspirants who assess this time.
Right.
Or even morning and evening shifts when there is drastic differences between the level of paper. Percentile also doesn't do the proper justice at times.
Correct. Depends on the question paper as well.
But that's how things are.
Right.
We have to adjust with it.
Yeah. So like if you have to give one piece of advice to the upcoming aspirants for again session 2,
revise the topics. I would say ki, remember certain topics are repeating again and again. Atomic structure formula if they could revise, just formula if they'll do, kinetics basic formula if they'll do. These are the questions which are appearing again and again.
Correct.
In organic, aromatic substitution is being asked again and again. In biomolecules, we are saying out of 2 papers have got that single letter code.
Correct.
So if they could find some mnemonic related to that single letter code, and just before exam also they could rhyme and go. And convert it to marks, you never know.
Right.
So these are the basic things for the next 3-4 days. And for the long term, we have already decided that read NCERT at least 3 to 4 times.
Yes, NCERT is the key. Yes?
NCERT including lab manual is a must.
Right.
Most of the students we have seen, they look down upon that NCERT and are more dependent on
the different
more number of questions, more number of modules, or they just are done offline coaching, searching online coaching, and wasting a lot of time.
Right.
In fact, if they go for NCERT, they can easily score, I think, 65% to 70% of the paper.
Right. Because the paper, paper is based out of NCERT, and then we also saw that from lab manual the questions are being asked. All right. So students, read NCERT 3 to 4 times. Don't ignore the lab manual, and also for the students who are appearing for the upcoming shifts, they should be aware of certain topics which ma'am has mentioned and go through these topics, and I think that would really help you for your upcoming shift. With that, we are at the end of this discussion. Thank you so much, ma'am, for being with us. And with that, we are at the end of this question paper discussion. See you for the upcoming question papers. Thank you.
Thank you.
For physics, we are having Srinivas Rao sir with us. Welcome, sir.
Thank you.
All right. So when you first saw the question paper, what is your reaction to it?
So it's a easy paper only. It is a straight formula based questions all are.
All right.
No twisting at all.
Yeah, we saw mathematics. Mathematics was also pretty easy. So basically the students are having a good time with this question paper, yes?
Yes.
All right. So now students, we have gotten the questions, but these are, let me tell you very clearly that these are the memory based questions from the students, right? So we have gotten 18 questions. So let us dive deep into each question discussion, right? So sir, what is your reaction to question number 1?
Yeah, the question number 1 is from the chapter surface tension, and it is directly formula based only. Work done is surface tension into increase in area.
All right. Easy peasy question.
Easy
Okay.
question.
All right. Let's go to question 2.
Question 2 is from geometrical optics. This is also direct formula based.
Formula based. All right. Let's go to question 3.
Question 3 is from nuclear physics. It is also direct only. Direct
All
formula
right.
based.
So we have gotten 3 direct questions. Okay. Question 4, sir.
4 also direct.
Direct. It's
Direct
from
formula.
coefficient of friction.
Yes.
Okay.
From friction chapter.
Right.
Hmm.
Okay. Question 5,
So
sir.
this is a conceptual question. It
Okay.
is also very less time taking.
Less time taking. Okay. Question number
So
6.
6 also direct only. All no twisting. This is from moment of inertia from rotational motion chapter.
All right. So like so far whatsoever questions we have seen is everything is direct. There is nothing much wherein you have to spend a lot of time. Let's go to question number 7, sir.
Question number 7 is also direct, but somewhat lengthy calculation. It takes somewhat more time.
Okay, so basically calculation is lengthy. The question and concepts are
Question
very
is,
easy.
direct only.
Okay. Question 8, sir.
Question 8 also direct. It is from kinetic theory of gases
KTG,
chapter.
yes. Yeah. All right. Question 9, sir.
Question 9 also direct only.
Is it? Okay.
But it takes some time for doing calculation. So it is also straight, no twisting in it.
No twisting in the language. Okay. So let's go to question number 10 then.
10 also direct.
Direct.
Direct only. It is from chapter LC oscillations from alternating current.
Okay.
Chapter name is alternating current. From that it is coming direct only, that is.
All right. Now it's time to go to question number 11.
Question number 11 also direct from current electricity chapter. So it also direct question, no need to spend much more time.
No need to spend more time. All right. Question 12, sir.
Question 12 is from electromagnetic waves.
Yeah.
So it takes somewhat more time and it needs some thinking also.
Or like, is it
A
conceptually?
little bit conceptual plus has to work out. It takes somewhat more time.
Somewhat more time. How do you rate this question, sir? Easy, moderate, hard?
It's somewhat tough.
Tough. All right. So we have gotten just one tough questions. Okay, fine. Question number 13, sir.
Question number 13 is direct formula based only. This is from optical instruments.
Okay. Yes. Telescope. All right. Question 14.
Question 14 also direct question only from work power energy chapter. Direct question only.
All right. Question number 15.
15 also direct. This is from diffraction chapter.
All right. Let's go to question number 16 then.
16 also direct only.
16 is also a direct question.
Formula based.
We have gotten all the questions. They are very pretty much straightforward and direct questions. Okay, let's go to question number 17, sir.
17 also direct, more formula based only. Time constant of circuit is C as direct. Simply, in one line we can tell the answer, right?
That's the experience of the teacher is that is saying that in one line he can predict the answer. I hope the students also will able to do it.
Yeah, everyone can do.
All right. Question number 18.
18 also very easy, direct, straight direct formula based.
Formula based question. All right. So we had 18 questions and we are done with the discussion, sir. So now when you see the entire question paper, like when you give the overview. Now if I have to ask you, how would you rate this question paper on a scale of 10?
Based on the toughness, can rate it as 6.
6. It's not very tough.
It's not very tough.
And what about the lengthiness of the paper?
Lengthiness, except a few questions, 2 or 3 questions only.
Were long, wherein either calculation is more or where you have to think more, right?
Right.
Okay, so how would you rate? Like overall rating is what, 6 or what? in
Based
terms
on
of lengthiness, yeah.
lengthiness, okay, we can give 4.
Alright, so it's 4 on terms of lengthiness, or in terms of difficulty it is just 6. So basically physics must have made the students happy.
Yeah.
Will we get more 100 percentile this time?
Yes.
Yeah, so that's the confidence of the teacher that is speaking. All right, we'll see more 100 percentiles this time.
Right.
So one piece of advice that you would like to give for the future aspirants who are going to appear for this, this session.
Okay, actually the students should go through each and every concept and each and every formula first. That's enough. If you forget any formula, then only you will lose marks. Otherwise, if you remember all formula and concepts, you can do 100%.
Right. So that's the thing, students, that you also have to do. Like, remember all the formulas, as we have discussed in mathematics also. Go through all the formulas, because you see that the question papers that we have seen in the past 2 shifts and this shift, including this, we have seen 3 shifts, right? So the question paper is not that difficult. So if you know the formula, if you memorize everything, I think this will be an easy walk for them, right? With that, we are done with the physics discussion. Thank you so much. Thank you, sir.
Thank you.